But they won't see me if I walk around, but I guess I'll stand instead of. Okay. Sorry, I just want to get back to. Okay, everybody online. Okay, so, all right, doesn't matter. I'm someone who has some experience in using computers to solve scientific problems, but over the years, I've developed a bit of a passion for solving, like, at least exploring data problems, okay? And so that's what today is about. We're going to be, so does everyone have this open on their computers? So it's a Google Colab notebook. Okay. This is what is our working document today. Today's going to be a code along. You need a Gmail account. You can use a burner Gmail account if you don't want to hook up your real Gmail to it. We will be putting something in your drive today. That's part of what we're doing. So if you don't want to pollute your drive, it's 2 files, no big deal. But the point is, we're going to be working off of this. You're going to need a Google account to get this going. So we are, there's this DOSCON conference, and the idea is we want to come up with a data hackathon. And so let's tie this to maybe the most intractable problem of our generation, which is climate change. There's a lot of data related to climate change. At the last COP, which was in Egypt, there was an entire sub-COP. COP was Congress of the Parties, this international climate change conference. There was, you can look it up, there was the data COP, that was when it happened in Egypt, where parties from all over the world said there's a lot of data that helps us understand what is happening with climate change. And we need to be a bit more organized as a community to understand where the problems are, where we have to concentrate our efforts. So I was inspired by that to say maybe that's what we should make our topic today. But the real goal, or what do I hope that all of you walk out of here with? Some of you have a lot of experience, you're going to find this a little easy. Some of you have less experience, and you might find this hard. We're going to try to get everyone down the middle. The goal today is that you should be able to, at the end of this 3 hours, be able to go get a data set and put it in a computational environment. Now you can do this when you get a data set and open it up in Excel, which I imagine everyone has done at some point. You've opened Excel at some point. You made a table at some point. You've made some kind of spreadsheet. A spreadsheet, like just a table in Excel. That's a computational environment. In there, you can write little formulas and say, give me the average or the maximum of this row. That is a computational environment. We're going to be using a different computational environment, a Colab notebook, but a Python-based computational environment. And so getting the data into there, that's one of the things we're going to work on. It's not a big, it's like one line of code, but that is a big accomplishment. Okay, to say I'm not limited to Excel, I can also load up data into something else. I can inspect it programmatically. Okay, and that's what we're going to be doing. We're going to go get a data set, put it in a computational environment, and then we're going to explore that data set. What does it mean to explore a data set? What are the typical questions when you guys go out into the world after to tackle our intractable problems? You're going to get these data sets, and then you're going to say, well, how do I start? What are the first few questions you should ask? Because I've been doing this for a couple of years, I've noticed that I'm always asking the same questions, and I'm hoping that you can walk away not having to do this for years before knowing what are the basic questions and how to answer those questions in this particular computational environment. We could be doing this whole thing in Excel, by the way. We could be doing it in R. For those of you who know, R is another programming language for data. Okay, we could have done it in a bunch of places. We're using Python because Python has built a bit of a nice ecosystem around some of the fancier things you can do with data. But before we get to the fancier things, we start with loading it, inspecting it, like exploring it. So I want you to be able to do that by the end. And then, to be the magic, is how do we combine two data sets together? So if I were to say what are like the learning objectives today, is to be able to load data, inspect and explore it, and then combine it with another data set. You can do that in any software suite or computational tool you want, but that, like, we're going to be doing it in Python. And we happen to be doing it with climate change data. Okay, we're going to be looking at global emissions by country. Any questions? Anyone not have this up and loaded on the screens? It's going to be a code along in the sense that I will be showing you the solutions. Okay, so you don't actually have to figure much out by yourselves. You just have to be here and listen, and I'll give you the answers. Okay, and then, well, I won't always give the answers. I'm going to try to figure it out. But you will, at the end of it, you'll have a completed notebook that answers a couple of the questions that I leave in bullet points, and you'll have done something. Yes.
We have to do a copy of that, or can we just?
Okay, I love that kind of logistical question. So I think the way it's going to happen is, so right now, what I'll do is, let me just show you some of the stuff that happens up here. So yeah, because not everybody's used Colab notebooks before, and some of the things are not intuitive. The idea is you opened it. Let me just. I shouldn't have done it. Okay. When you're looking over here, you might not, do you see a check mark? Oh, so you are connected already. Okay. There was a little bit of magic that I would have liked to just like dive into a little bit. When you opened it to start, when you opened the link and if you didn't click the connect, some of you have seen this in the AI launch side, some of you have not. I want to take my time with it. We're going to really go into all the things that I think we should all appreciate. When you click connect, you have, originally you just got basically a Colab notebook, which is basically a JSON. It's a file. We open it through this web interface. But if you ever look at your file directory, what am I even looking at? It's just a file. If you open it to a text editor, it's just going to be like a dictionary for those of you who've gone a little bit further in Python. And so you open the file, but when you connect, you are now on a little virtual machine hosted by Google. Okay? And I think what's going to happen is it's going to, if you try to make any changes, because it's going to ask you, do you want to make a copy? And you'll be making a copy, which is going to be stored in your Google Drive attached to that account. You can view it, okay, the whole time, but I think I'm the only one who's an editor. So you'll be actually forced to make a copy to answer that question. And you will be making a copy of this file in your drive. If you ever want to know where did that file go, it's somewhere in your drive. Google will put it there for you. That's why you have to sign in. And then you'll be able to edit it and whatever. If you don't click the connect button, you can actually do this. You can look at what's happening without signing in. But to make an edit, you have to sign in. And you copy on inherently. Any other questions? Okay. You guys can see all my Slack messages up there. Okay. We're not using Slack to communicate, so I can turn it off. Okay. Yeah. I wasn't sure if I was using, but I'm just going to quit Slack. Okay. Good. We're not. Oh yeah, I couldn't get onto Discord because I'm old. Okay, so we're doing this. That's like I would say the concrete for this morning. Why? Well, it's an intractable problem. I think it's a superpower that a lot of people do not have, which is the ability to programmatically play with data. So why can't I just do this in Excel? What's the advantage of doing it in Python? I heard you say something about, well, doing it in Python allows me to maybe get ready to use like machine learning tools at some point, because there's a lot of really good machine learning tools in Python. But there's something else. When you do something in Excel, like calculate the average of a column, make a pivot table, which also not a lot of people know how to do, and I think everybody should learn how to do. But when you do that, you have to go and click and click and click. And then if I say do it again for a different inset, oh man, I gotta do it again. I gotta click and click and click. It's not programmatic. Python is programmatic. you will write basically little commands that will calculate the average of a column. Give me the number of categories in a particular categorical column. And that line of code that you will do to execute those things will be ready for you the next time you load a different data set. You can write loops to say, oh, can you do this over the next 100 files I feed in? So programmatically doing data analysis has an advantage compared to doing data analysis in Excel, which is manual, because you create a recipe to do it later. So, I gotta do it. Yeah, I want to say that. Why we're doing this? Oh, and why? So why? One, I want you to be able to do programmatic data analysis. Second, we want you to be thinking about climate. I think every opportunity I, as a teacher, I want to spend it talking about climate change. It's an intractable problem for our generation. But why is also that this is part of a 2-day challenge. I'm going to spend about 2 hours-ish, an hour and a half at this point, I guess, talking about how to do certain data things in Python with Pandas, which is our library, how to make a graph, this and that. But after that, my co-host, Vanessa, who's also a teacher at Dawson, is going to come and say, okay, well, how do we think about taking these kinds of analyses and spinning them up into a story? How do we do data journalism? For those of you who are on the New York Times, Radio Canada, CBC, sometimes do it, but the New York Times is very famous for this kind of thing. They just, you open up an article and you scroll on your phone, and I mean, the famous examples are from the Upshot, where my favorite example is when you see a graph that is interactive, where you can pick the NBA player, and they'll basically show to you through a visual graphic. They'll make the argument saying Steph Curry truly is the greatest three-pointer of all time, because you make this graph that shows like how quickly he got to his point total today, and he did it super early in his career. But it's an interactive graph, and that graph was a part of a larger story they were trying to tell, and I would call that data journalism. And it's becoming more and more common in the mainstream media, and we'd like you to consider, could I do that? Could I do some data journalism? Can I tell a story that includes some computational analysis, some kind of graph, and we'll make the topic climate change? But Vanessa will be showing like how should you be framing your story, and then that'll finish at 1 o'clock, and then you'll be on your own. Okay, we're just going to leave. We're going to be here to mentor you, but we're not going to need help. You will get into teams, and you will tackle making your own data journalism story, and you'll have 20 hours to do it, and you'll be submitting it tomorrow for some grand prize, where we'll be judges and we'll be evaluating you, and you'll submit a story that is a data journalism story that has to do with climate change. Any questions? Okay. The data journalism story we're going to ask you, we're going to release it, is going to have to do with Canadian emissions data. Okay, and I will show you how to get that data, but I will not show you how to manipulate it, because I'm going to show you how to manipulate similar data at the international level. So basically, we're going to spend 2 hours and a bit doing analysis of emissions, carbon dioxide emissions by country over time. We're going to practice our skills on that data. Vanessa's going to talk, explaining how to frame that in type of a story. And then we'll set you off with Canadian provincial level data, and you will do roughly the same analysis, but your imagination, that'll be like the starting point. And then we're going to let you kind of come up with your own stories. Yes.
Just a quick comment, because this is being recorded and people are attending hybrid currently. When that recording is done, it will be produced and made available. So later on, you want to review some of these things, maybe it went too fast, maybe you'd like to pause for a moment and try what is being demonstrated. You'll have that as a resource as well. Over time, just stay active on Discord. We'll be putting some tips into the channel resources channel, as well as the release of the challenge itself.
All right. Any questions? Okay, so we're all connected, we're all signed into Google. Let's get going. So first of all, one of the nice things I like about Colab notebooks is that they allow you, there's a couple of big ideas that we're talking about. One of them is called reproducible research. Like if you had done this analysis in a spreadsheet software like Excel, unless you get really good and write certain VBA scripts or something like that, the point is it's not reproducible. It's that what did you click to make that graph? There's no documentation. You have to write down, well, you hit this button, then you hit that button, then you hit this button. Whereas when you do it programmatically, it leaves a trace. But Google Colab goes one, or any Python notebook goes one step further. You can insert text with your code, with your graph. So when you produce a report, you have the code and your analysis all in one place. So I was able to insert text, and I can edit that text. You know, I can format it, whatever, and you should be able to too in your own copies. You won't be messing with mine. You don't have to worry about that. All right, so what does he want me to do? Okay, first in my setup, the first step in any data analysis project is identify your data source. We will be looking at our world and data. So let's click it and see where it takes us. Now, our world and data, I would argue, so some of you might wonder, I really don't know what you want to do. This is your inspiration. This is maybe some of the best examples of data journalism out there on that website called Our World in Data. They don't just talk about climate change data. This is one of the articles on that website. But I encourage you, peruse the website. There's tons of topics. Okay. And this is a great example of what data journalism could look like. I gave you the upshot as an example on the New York Times. Another one is Our World in Data. And they go one step further. Is that they will make the data that's behind any of their articles available. So not only will we be looking at the article as an example, we'll actually be taking their data and trying to recreate what they did. Try to get as good as the pros, because these are the pros. Okay. So I'm looking at this article, and it seems like I can pick countries, but there's tons of sub-points of the article, but I really want you looking here, and it seems like this is really advanced. I'm not convinced. Some of you might have the ninja skills in 20 hours to produce something as interactive as this. This is a data journalism article with text and research and graphs and data all put together, but it's interactive. I can say, I want to look up Canada here. And it takes me to a site and creates graphs and animates them. This is next level data journalism. But I encourage you to be inspired to say, this is something you want to work on. Because this is how we make arguments and convince people, I would say. Okay, so I'm looking at this. What are this country's annual emissions? I can add a country. I don't know. Let's do the United States. Let's got the United Kingdom. And see what it looks like. Okay, and now you can see, what am I looking at? I'm looking at annual CO2 emissions from fossil fuels and industry. Land use change is not included. That's important. It's going to be super important to start thinking about, okay, when I'm looking at data, what are the names of my columns and what does each column mean? Okay, you can imagine that this came from a data set where you had year level annual observations and country and amount of CO2 emissions, and then you can make a graph. One of the takeaways that you walk out of here with today is you will be able to make that graph. Okay, and programmatically, not necessarily in a web-based format like this. Like, I can't even do that. It's like high-end JavaScript. There's like other technologies involved to make it look and feel like, because this will look good on your phone too. So this is, for those of you who are inspired by this, I encourage you to take this further and further and further and become like the technologies behind this are all open source. And I know that anyone in this room could, with a couple of months of practice, be able to make stuff like this. But you're going to be able to make one like a graph like this programmatically by the end of today. In fact, we're going to do it again. Okay, so that's cool. I see something. I would like to now get this data. Let's go get the data. You can see. So is everybody on this page? Because you have to be. You have to get the data. I can't put the data on your screens. There will, right? So if you're on this page, and I really need you to make sure you're looking at what are the country's annual CO2 emissions. You need to be looking at that. Okay. There's other, because there's hundreds of graphs, I mean, not hundreds, but there's like tens of graphs. This is, you know, year on change. There's tons of stuff here. I want you to get to the part that says countries' annual CO2 emissions. We're good? All right, go to the little download button. The tab, sorry, I'll call it a tab. There's a tab at the bottom that says download, click that. And we're going to get the full data in CSV. You're going to download it, it's going to show up on your computers. I've done it twice, which is why you have a little two of it. So you have now that data on your thing. If you open it locally, I'm imagining, depending on what computer you're using, it's going to open up a spreadsheet software. It might open up a text editor. It depends how you have your computer set up. But take a look at it. What does it look like? I'll open it up. If I click it, I now have this on my computer. I don't have Excel, I have LibreOffice, but depending on what you have, let's open it up. Let's take a look. And I have a spreadsheet. I have CSV, for those who haven't heard that, it's comma separated values. Okay? If you actually open this in just a text editor, not a spreadsheet software, you would have seen like the country name, then comma, AFG, comma, comma, and then enter. But the spreadsheet software separates it into columns. But this is what it is, right? I see this country, this is Afghanistan, I've got some code, I've got the year, I've got the annual CO2 emissions. I can scroll down, see what else is. Oh, okay. So I've got my continent also. Okay, I've got a lot of countries. This is a lot. You know, this is a very large data set. And we could say we're just going to live in my spreadsheet software, which can be useful. Okay, I've been doing this for a long time. I know that sometimes people start Python and we get excited at what it can do, but it can be a bit intimidating. I don't think that's the case for the people in this room. I think everyone here is related to AI Launch Lab, or you're here because you want to learn Python. But let's say someday you left Python behind and it's like, oh, I wish I did more of it, but I didn't. You can do everything we're doing today in a spreadsheet software. It can be pivot tables, and it can be very empowering to not have to get into some kind of fancy computational environment. I don't want to solve Python. I don't want to do this. You don't have to get bogged down by that kind of. Sorry, I got distracted. I think everybody say hi to our academic dean who's just walking in. This is the academic dean of Delta College. I got distracted. Yeah. Sorry. Okay, so you have the point is everything I'm going to do today. If you at the end of today or any point if I'm walking around after say, could you just show me how to do this in Excel? I'd be happy to do it. It's very empowering to say I don't need anything crazy like Python new age. I can actually do this in the things that are installed on most computers. Excel is going to be installed on every computer in your lives from now going forward, right? And so if you don't want to get into Python, you get intimidated by Python, it's fine. I'd be happy to show you how to do the same analyses non-programmatically. And it's very empowering to be able to do that as well, not having to rely on Python, whatever that is, right? So just so you know, okay. But this is what you just downloaded, and you all have this. The next challenge, like I mentioned earlier, is how do I get this into that computational environment, which is like in the Google Colab. Okay, so this part is a little bit of clicking and understanding. You're going to, oh, I don't know if everybody saw that. Okay, anyway, we're going to go back. Yeah, okay, we're good. We're going to go to your drive. Go to your drive.google.com. You have a cloud-based place to store this data. You're going to upload this data anywhere you want into your drive. I don't care. You can make a new folder for today. I made a folder for today. I actually have a folder called, I mean, you can call it whatever you want, but I have a folder called Teaching Public. And if I look in there, I made a folder for DOSCON 2023, and I uploaded my data in there. You have to do the same for yourself. While you're doing that, I'm just going to say a very important point. There are a lot of data like tutorials out there. I'm giving you one. I might be going a little slow for some of you. I might be going fast for you, but I'm sure some of you have seen that there's so many machine learning, data science tutorials out there. And often we work with what's called public data set in those tutorials. And those public data sets are available via URL. And if you're clever about it, you can get that URL, plug it into your own Colab, and it just works. And that's our public data set, and that's fine. But you will go off into the world. First of all, you have to be careful. What does a public data set mean? It means that the people who collected that data have signed off and saying, we're happy with anybody in the future without our knowledge using it for something else. That's a very particular criteria. And I want you all to reflect as you go on and work on whatever projects you work on. I would argue it takes a long time for any data that you collect is probably not public. You will all be working on data sets from your research, in your jobs, and they're more than it takes a long time to make a data set public. So I'm showing you the pipeline and process to how do I work with a data set that's not public, that I can't get to a URL. You can put it in a drive. The drive is not public, that belongs to you. And you're going to make it accessible in your computational environment through your own password and whatever. I'm asking you all to be careful to never, ever, ever make a data set that comes across you available by a URL. Because once it's available by a URL, you've kind of made it public. It can be easy to just say, yeah, but who would know the URL? You guys know the URLs behind some of these things. Who's gonna ever guess that? We can find everything on the internet. Okay, so please just use, I'm taking an extra bit of time here to say, going forward, you have a data set, be super aware of, am I making this public? Because it's actually public and not just easier. It's very easy to make these things public. Publish the web, and all of a sudden anybody can see it. Never do that unless you are certain that all of the people who are involved in the collection of that data have consented. And it's not just the people, like let's say we're doing country emission data. Is that really public? Is any privacy involved there? But you could be working on census data. You could be using medical records. You have to be incredibly careful, and it's just now we have the tools that make it so easy to make these things public for our own analyses. Just be very aware of that. So even though this is a public data set, I was able to download it on a public website, I'm treating it like a private data set. I'm putting it in my drive, and I'm making sure that my analysis, like my hook from my computational environment to my private drive, is going to happen through a password that not everybody could just do. Okay, so you've done that. Everybody's got the data set downloaded and put into their drive. Okay, you go do some scientific experiment. You want to do this again, you'll be able to do it. Just put it in your drive. And now I'm going to show you how to get it from your drive into the computational environment. We're going to go back to the Colab. Right? We need to make that. This is my comment here. What we're trying to do is we're trying to make that data available here. So we're going to import a library. So I'm imagining this isn't the first time. Most people here are from AI Launch Lab. And so you've done some Python, so you understand what it means to import a library. We're going to import a particular library. Sorry. From Google.colab. So Google is the big the Python package. In that Python package, there is the Colab sub package, and we just want to import one part of it, which is the drive functionality. And if you execute that cell, well, it didn't complain, so at least I know I've imported that library. And this drive functionality, I'm just going to do it in the same cell, will allow me drive, dot mount. Okay, so we want to mount it. Mounting, I want you to imagine what that is. If I had given this to you on a USB stick, you would take the USB stick and plug it in. The key terms called mounting. So we're going to mount everything that's in the drive, which is your personal storage space, into this computational environment, this little virtual machine that Google set up for us somewhere. Okay, so drive.mount. This is a little annoying. You have to write content
I hope this works. I practiced, I was rehearsing, and I feel like I don't remember this word. Aha.
Permit this notebook to access your Google Drive files? You can say no thanks, but I'm gonna say yes, this is my Google Drive, right? So this is like a private thing you guys are doing for yourselves. You're gonna have to put your passwords and I can't see what you're doing and you can't access what I'm doing. You have to do this for yourself. So yes, I'm gonna connect to Google Drive. This is gonna happen. This is the evidence that I have not made it public, right? If it was public, it would have just connected and I would have had it. It's not public. Your drive is not public. It's behind your password. So now you have to connect. You're gonna, so you got to be careful here, which is why sometimes you might want to use a burner Gmail account. You can decide what you want. It is giving you access because now, but this is actually kind of cool. I've used this functionality once to clean up my drive. You know, I have like 10, 15 years of photos and I had to clean them up. I was able to access my photos from there. Felt a little bit like a hacker when I was doing that. Anyway, nonetheless, yes, you can access all of the things from inside that notebook. So allow. It's thinking and it should work. You have to put that little /content/drive. Okay, so I think you're mounting only one part of your entire Google Drive. I think it's all there. Okay. Any questions? Yes. Is it working for some? Okay, so I can, Richard, you want to? Okay, we're gonna get somebody. And I'll pause in a second. Once I get everybody going. So if you guys get stuck, so I'm gonna just as a little outline, I'm gonna get everybody, or as many people as possible. I'm gonna get everybody into this section where you start answering questions. Then I'll come around and see if anybody's actually stuck and get everybody in the same place. Then I'll continue. So if you are stuck, you can take a breather. I'll come around and get you unstuck hopefully soon. Or Victor will come around. Don't panic. We have we have lots of time today to get this right. But do some people have this going? Smile and nod is good for me. Right, thank you. Okay. Next. So if you see up here, there's a little folder. My computational environment has access to a local storage. There's some virtual machine that Google has made for each one of us somewhere. And I have this little machine. And so that little machine is running code interactively through the web, but it's also got some storage. Drive is where I want to go. So if you click that, you will see my drive. And then you'll see all your stuff. Like this is my stuff. I remember I said I put my stuff in Teaching Public. And then I made a folder called DOSCon 2023. It's right there. Those files. Yes?
When running that command, should I click on connect to Google Drive?
Yes. Yes. Absolutely. You do need to make a connection between the computational environment, this CoLab notebook, where the computations are being done, where the Python code is being executed. You're making a connection between that and your Google Drive, which is like a storage space for you. Okay, you're making a live connection there. And it's your connection, not a public connection. And so what I want you to do, I don't want you to click the file that you did. It was annual CO2 emissions, right? I want you to click the 3 dots and you're going to copy the path because there is a path to get there. It's a file path. Okay, it's like go to this drive, this folder, but you're going to copy the path. And once you copy the path, okay, here you're going to open up a new code chunk and write, I like writing FP for file path. It's just a variable. You can call it whatever you want. You're going to put some quotes. I can make this bigger. So I'm in this cell here. What I did, just if I went a little fast, I found the folder by clicking on the directory at the left. I went here, I found it, the file.
I clicked on the 3 dots and I did copy path. And I'm going to put that as a variable. You can call it FP, you can call it whatever you want, and paste it in there. I'm going to zoom out so everybody can see what the result is there. So as a string, you have FP equals quotes and then some long path. Okay, and now
The magic is about to happen. I personally think it's easy magic, but it's magic.
now that you have that,
It's a little long for me, so it's hard to see. I'm going to close my directory structure so we can have more of the screen back. Okay, but that's a file. What do you want me to do with that?
you can write FP, it's just going to give you the string back.
I want to get this into some kind of thing that Python can manipulate. And so now we're getting into a library of Python called pandas. It's spelled like the word panda in plural, and so you could say pandas, but I'm pretty sure when we talk about it as a library, I don't know why they named it that, but it's called pandas. And pandas is what I would call Excel for Python. Okay, so spreadsheet, how do I get the stuff I can do in Excel, but do it in Python? You use pandas. That's our workhorse today. That's our big hammer. That's our tool today. We're going to be doing pandas today. Okay, because we're going to learn how to programmatically calculate the average of a column, find the most important categories of data, something in a spreadsheet, okay, via pandas.
So I have to import it.
So I'm going to write import pandas. Now,
some of you saw this in Python. You import libraries, but sometimes you don't want to call them all the time by the name. Pandas is a lot to write all the time.
So I'm going to write import pandas as convention is to say PD.
Okay, so now when I want to use the pandas functionality, I'm going to write PD dot something. So I've imported, I'm going to import the library.
and then I'm going to do PD, so pandas dot read CSV.
So I want, yes? It's not showing up in the folder here?
I clicked, can I do something, but I can't get back to like where it says like the time.
Okay, so just give me a second, I'm gonna come help you with that, okay? Anybody who's stuck, don't worry, we're not gonna go much further than, once I got most people here loaded, I'll take a pause, we'll walk around, make sure everybody's caught up, okay?
I want pandas to read some file. But what's nice about pandas is I don't have to give it the file. I can even just give it the path to the file. So I can write FP there. And if I execute that cell, holy moly, what just happened? I got that spreadsheet that we saw.
And Excel is now here, it just came back, and I have it, it's actually formatted. Pandas went on the internet, found this as a path, and loaded it, figured out the commas, figured out the this, figured out the data types, and just got it all here. And it gave me back something. So that thing, I want to store it.
And so in fact, I'm actually going to do one little piece here. I'm going to write DF. You could call it whatever you want. It's another variable.
And that DF, you call it DF, you can call it whatever you want. Call it X, call it Y, you call it data, you call it whatever you want. I like using DF, it's the common for data frame. Data frame is a word you're gonna hear more and more, but it basically means a spreadsheet, whatever you want to call it. So data frame, whatever comes back from pandas library, read CSV's function, I fed into it the argument, the file path, it gave me something back. Now I want to store it so I can keep working on it. That is now DF. And now I'll be able to just say, well, what did come back?
can I look at it some more? So when I run that, and then I write df, I get the same thing. It goes, gets it, and then remember in Colab notebooks, the output that's shown, right? This is the input. This is like computer go do this. Computer goes does that. This little arrow means what did the computer send back? It'll always output whatever you did in the last line. And so if I had not written df there, if I had just done this, just doing it over and over so everybody sees, look, no output. Where's the output? I wanted that nice table back. Well, it's stored in df, and the last line didn't give me an output back. It just stored it inside df. Okay. All right. So now that it's stored there, let's just, I want to know what I have here. So I want to explore it. Yes. Light mode would be better? Yeah. Sure. I didn't practice how to do that. Give me a second. Do you know how to not put it in light mode? Better? Sorry, I should have done that at the beginning. Okay, what I'm going to do is I'm going to take a second to introduce you to my favorite web page. If you open up a new tab and just write pandas, you should get to the pandas documentation, the docs. Okay, and I'm going to give everybody a little bit of time to click around here. There's a great getting started. I think you guys are all new to pandas. While I just want to take a couple of minutes to make sure everybody's caught up. We're right on schedule, so don't have to worry about anything. In terms of timing, take a couple of minutes. I'm going to walk around, make sure everybody feels comfortable. But if you click in here, there's like a 10-minute tutorial. You want to click around and try to get familiar with the pandas documentation. Okay, what can I do when I have a DF? DF is like a data frame. I think they call all of their data frames in their tutorials DF. Click around. Just don't be shy. Just write DF dot, I don't know, anything. See what you get. Well, I'm just going to make sure everybody's all caught up. Just like 3 minutes. Just give me 3 minutes and feel free to explore the pandas documentation and what you have in that DF variable now. Not make it in there. But I want to make sure everybody has got the data and the DF loaded. Don't? That's what I want to solve. I want you to write hold on, let me just get the collab back up. Yeah.
Anybody else not have the data frame available?
I will be sharing. Okay, df.columns. Nice. First question. Next question. What does each row represent? Well, that's a good question. I think that's not, there's no
command that'll be like, well, maybe ChatGPT could do this, but there's no command that'll say that's thinking. We have to look at the data to understand what each row might need.
Here you have to use your human intelligence to do that. What I like doing is I like looking at the top 10 rows.
So if I write df.head, head means go to the head of the file. Give me, and 10 means 10 rows, so 20. If you don't put anything, it'll give you 5 by default.
Okay. And if I hit that, what I'll see is this, and maybe I can, oh, okay.
I've got the same country over and over again. It's got a code. I've got a year and the emission. So my answer to the question is each row in this data set represents the amount of emissions for a country in a given year. Okay?
That's the answer to that question. Now, maybe I want to be sure about it. So what it says, maybe I can look at the end of the data set, because maybe the beginning of the data set is different. So I can look at the last 10 files, 10 rows. So df.head gave me the top 10 rows. df.tail gives me the bottom 10 rows. Seems to follow the same pattern. So another country, year by year, oh, it looks like there seems to be some chronological order. It looks like my data goes to about 2020, 2021. We have no way of knowing, and we would have to do analysis to say, well, I wonder if I have all the years for all those countries. You probably do. You will not. I think all the time. Yeah. A lot of times people put data sets together and then they say, oh, well, that country doesn't have all the years. That can happen. But I'm pretty sure in this data set, you have to do your own ninja work to see, do I have all the years and all the countries? That's part of data analysis and process. Okay. What if I want to be really careful? I'm worried that it gets messed up. And actually, my favorite, instead of looking at head and tail, I like sampling. Now I want to make sure I understand this data set. I want Pandas to give me 10 random rows. I don't want to by accident download a data set and the top of the file is okay, the bottom of the file is okay, but there's a bunch of mess in the middle. So what I'm going to do is I'm going to sample 10 random rows, just make sure my pattern makes sense, that I think I understand what's in this data. And I'll get 10 random rows. If you hit that cell over and over and over again, you'll get a different result every time. So what I like to do when I'm doing data analysis like this is I'll take my data set and I'll just sample over and over and over again, look at it, and does my hypothesis make sense? Do I understand what this data set is? And it does. I have countries, I have years, I have emissions. Every row represents the emissions for a country in a given year. Hit it again, you'll get 10 more random rows, and it will confirm that that is this data set. So now I have a feel for this data set. I'm internalizing what this thing means. All right. So we answered that question. What does each row represent? I'm just going to, all right. I'm going to copy that, put it as a comment. There's no command, but I would say head, tail, and sample. Allows me to figure that out. How many rows does my data set have? So we're going to open up a new code chunk, right? To open up a new code chunk, I hover between two cells, hit plus. I'll put a little comment here. So now I want to know what the shape of my spreadsheet is, my table, my data frame. So that's df dot, unsurprisingly, shape. And it will give you back a tuple. Tuple being Python, a pair of numbers, like coordinates. And it has 31,000 rows and 4 columns. And we know the 4 columns, we saw that, right? When we get a visual of the data, we see the 4 columns. And 31,349 rows. It's important to know that. Does that make sense? I think so. I don't know. How many countries are there? Well, we should probably have an answer that question. So I will show you the answer to that question. But let's see, 31,000 rows makes any sense. Because you have to be able to do these estimates. So like, I don't know if that's a lot or a little. Am I big data now? I'll tell you, spoiler alert, this is not big data. Big data is like when you're dealing, just looking at the size of the file was, I think, in the kilobytes. Okay, that's not big data, but 31,000 rows is a lot. It's not something you can do manually. So let's now explore to make sure. So this wasn't a particular prompt, but we're going to do what I would do now to make sure that that number makes some sense. Can I do a back of the envelope approximation to say 31,000 rows makes some sense? Question, sorry.
So let's go with the 0 inverse of the row. So there's a 1,049 rows. How come there's no 5 columns? Like there's one row for the header, but there's no like It's the amount of the,
Columns
yeah,
does not include the index.
it does not include the object.
And it's absolutely true. That's a Pandas thing. Pandas is storing it has an index column that's in bold, and that doesn't count in the number of columns.
But then the headers,
The header doesn't count either.
it's counting.
It is counting?
Yeah.
Oh, so then, well, oh no, it's because the first row in Pandas is the 0th row. So it is, and that's why the last index number here that you see at the bottom of your DF, when you DF.tail, will be 31,348, because it started its first row at 0, which is a Python specific thing. In Excel, the first row is the 1 row as the header. And if you put something, it goes to 2. But here, everything in Python is a 0 index language. Everything in Python that's stored always with 0 as the first one. That's a great question. It's a very Python specific question. That has it. Right.
All right. Okay, I want to do some calculating, figuring out, and in the meantime, show you some stuff. So I'm going to make a little comment here. Does this number of rows make sense? Little extra, a little bonus, little gravy for today's lesson.
I did not plan on doing this, but I just realized we should do this. This is a common sense sanity check.
Well, what I want to do first of all is say, how many countries are there? So what I'm going to do is I'm going to do DF. I want to just get the entity column.
So if you want one column of the data frame, you take the name of that column, put it in quotes, and then put that in square brackets after DF. So it's not DF dot. You actually could do DF dot entity, but I hate that. I like using it as a string. Okay, for those of you who've done this before, you know this. You may be saying, oh, I could just DF dot entity. The reason I don't like doing DF dot entity, for those of you who are asking why don't I do DF dot entity, the reason is because sometimes column names have spaces in them, have wacky characters in them. Like today, CO2 emissions as 2 is a subscript. Okay, DF dot is not going to love that. So that's why I'm not doing DF dot. To get to a column name, my go-to way of doing this is to get this column name as a string. I know its entity. If I want it, right, like here, I'll prove it. Watch this. I don't want that column.
I want the CO2 emissions column. What I'm going to do, this is why df.columns is useful, because now I can just go here, copy this, because how am I going to put a See, I can copy this, Control C that, and I could paste that into and get just that column.
But if you try to dot that, I don't know how it works. I don't know how to dot something that comes in with a subscript in it, with a space in the title. So that's why. But you could access any of the columns. So how do I access the first question? How do I access a column of a table? You take the name of the data frame, you put square brackets, you put quotes, and then you put the name of the column you want. But that wasn't my question. My question wasn't about emissions. My question was about
the countries. So let's go back here. Let's delete this. So I've got the countries.
Without going too deep in what Pandas is, but because you're going to read the documentation, you want to be able to know. When you have a full spreadsheet and it prints it out that nice way, you saw like when I did .head, .tail, or just DF.
DF is a data frame. It's the table. Okay, this is a data frame. But this, why isn't this printed nicely? I want that nice formatting, because this is not a data frame anymore.
This is a part of a data frame. It's a column. And when you're working with a column in a table, a column in a data frame, Pandas gives it a special name. It's called anybody know? It's called a series. So if you see Pandas referring to a series in the documentation, in a tutorial, or something, they're talking about one column. And when Pandas spits out a column, it doesn't format it nicely, it just gives it back to you as the column. So I have the series,
But that's the countries, but I want to know how many there are. This is maybe my favorite command. Dot value counts.
okay? If you were in Excel, you'd be making a pivot table to get this answer. If you do dot value counts, what it's gonna do is I know that this is called a categorical variable. When we think in science, or really anywhere, when you do any kind of data, you're working with data, you've got variables, columns, and sometimes it's numerical things in there. We call that a continuous variable. And sometimes it's a discrete variable, like that's not numbers, it's always not a number. It's a category. So it's a categorical variable. And whenever you have a categorical variable, you want to know how many categories do I have and how many things are in each category. So value counts does all of that for me. It's my favorite command because the reason it's my favorite command is because, what's your problem? Oh, I'm missing an S. The reason it's my favorite command is because to do that in Excel is at least 3 or 4 clicks. And here, I just write it once. Also, to do it in Excel, every version of Excel has a different way to make it. That's annoying. One way to do it for any data frame. And now what I see here is I seem to have, so dot value counts actually gives me back another series. That's why it's printed like that. And what I see is Europe is a category, and it was 272 times in my data. And South America is, so those don't look like countries, those look like continents, and where did my other ones go? And what you notice right away is some of the countries do not have every year available. But my guess is looking at this is that I have 272 years of data per country. For most countries. Yes? Great question. Because of what I did earlier, I saw that the data set, each row represented a country, a year, and the amount of emissions. What dot value counts doesn't know that. Dot value counts is saying, look, you gave me a series of countries. You gave me a series of categories. All it's doing is counting up each time each one of those things showed up. And so it's hard to see because it gets cut off, but let's say I do
This dot head 20. Okay, so take the series, do dot head, do dot 20. Now I'm seeing, here's an example. Singapore could have been a country somewhere in the middle.
And that word Singapore showed up 272 times. And Singapore showed up 272 times, and I did in my previous testing of the data set saw that each row was the country for a year and its emissions. I'm making the assumption that in fact I have 272 years of data for Singapore. I have because it shows up 272 times. It's a good question. The answer to that comes from what we did before. And so what did each row represent anyway? This is only operating on the entity, the country name column. And all this is doing, dot value counts, is saying how many times does each of the things show up? If I were to say, what's value counts doing? It's taking the long row of all the country names. And it's making tiles. Okay, Afghanistan showed up, put it in that one. Oh, it showed up again, it showed up again, it showed up again, it showed up 272 times. So Afghanistan, 272. Oh, Zimbabwe. How many times does it show up? Makes a pile. And all the piles, how many are in each pile? Okay? If you want,
You can also do, instead of value counts dot head, you can do value counts dot sort index. Oh, Afghanistan only had 73 entries, it turns out. Okay, I know I went fast there. I'm going to tell you what I'm doing.
because the dot value counts, what it does is it gives you back the count of piles it made in order of frequency. So 272 was the top, and at the bottom, it gave you like what were the least frequent categories. Okay, but what I want to do is sort it in out because my file was in alphabetical order by country. So if I want to see it the way I saw it in the data, well, you do dot sort index, because the index was the country. And what I see here was Afghanistan, which was my top one. It showed up 73 times. When I did dot value count, and I said, like, if I were to be a cartoon version of the value counts command, I'm going down the entity column. I see Afghanistan, put it in a pile, put it in a pile, put it in a pile. And at the 73rd row, I made 73 counts of Afghanistan. Then I go to the next country, I see it again, I make a new pile. The next column must have been Africa, I guess. And that one showed up 272 times. So it seems like we have global emissions for the whole continent of Africa for 272 years. But Afghanistan, we only have for 73 years. And for Albania, we have for 89 years. In Algeria, so my question before, how am I supposed to know if I have the same amount of data for all of my categories? This is the only way. That's why I'm taking my time to make sure you guys get through it. Yeah.
If you have Asia, for example, all the countries are in Asia, that's
I agree with you, but that is the type of question you ask when you can do this analysis. That's a great question, but I don't have the answer to that, neither does Pandas. But that's a very valuable question. What does this even mean that Asia is here 272 times, but then it's here GCP 172 times? What does that even mean? I don't know. Pandas can't answer that question. That's you as humans who can do. But my point is, my favorite reason I'm is because I'm learning a tool that gets me to ask the right question. But if I didn't have Pandas, how would you even get that question? That is a great question to take to the people that are the data. Why did it make it? How can you post it? The data set is very confusing. That's a good question. Look, I did this analysis. I wrote one line in Pandas, but something doesn't make sense. But that's a question that Pandas can answer. But it gives us the tool to even ask that question. Yes.
So value counts, they order it in order of frequency, but if they have the same frequency that's not in the how do they order it?
I think the second is by the index itself. Yeah, that's why it started with like the first comment.
Okay.
So if I alphabetical in the index. So Pandas does its own thinking. Like it decided to do that, you would have to read the Pandas documentation to understand it. Well, why did it do that? Well, Pandas internally has a default parameter that if the frequency comes out equivalent, how am I going to sort it? I'm sorting alphabetically on the index. Great. That's like a deeper Pandas question. And to answer that for sure, I have to go deep into Pandas documentation to say, okay, dot value counts, what is the documentation for that command? And you will find that explicitly written.
Pandas is like coding with Python. It's like
Pandas is coding for spreadsheets in Python.
okay.
That's its job.
Like a sub.
It's a sub part of Python. There is, like, let's say I wanted to work with maps. Pandas is, well, actually, Pandas could help you a little bit with that, but anyway, because Pandas does a lot of things. Or let's say I wanted to work with, I want to make graphs. I could use Pandas, but really, Python is the big circle. Pandas is a little circle inside it, and it does one specific thing in Python. It does spreadsheet analysis. But if I wanted to work on just making graphs, I'm going to use matplotlib and Seaborn. Those are two other packages that we are going to use today to make the graph. If I wanted to work with maps, I would use some other thing called GeoPandas. If I wanted to make a website in Python, I'd use Django. Okay? If I wanted to do scientific computing in Python, I would use SciPy. If I wanted to operate on very weird numbers, I'd use NumPy. So Pandas is one of the small circles inside it with a very important but small role, which is specifically working with spreadsheets, tables, data.
Any other questions? Yeah.
in order, like,
Initially, that was the default.
If I don't do sort index, if I just do dot value counts,
It puts the most frequent categories up top. Most frequent categories come up top. And if I did sort values,
well, that it's like it already did, but sort index allowed me to make it, okay, I want you to order this
differently. I don't want the most frequent categories at the top. I want it sorted on this thing. This is the index because the countries that like in alphabetical order. So that's why I wrote dot sort index. And then I can do dot head on that because that allows me to get the top 20 of this new thing. Because that happens a lot. I have a data set. I just want the top 20 most frequent things. So this is how you would get there.
Good. Okay, so now that I see that, oh,
Brother, but does the rows make any sense? 31,000 rows. What I see here, how many countries are there? Doesn't mean 200. There are 258 categories in the entity column. How did I see that? Down here? Okay, because this series that got spit back has 258. It can't show you, it shows you the top 5 and the bottom 5, but then it tells you that it has 258 things in this. But this is the count of piles. Value counts went and made a bunch of piles. How many piles did it make? 258 piles. And what this is telling you is how many counts are there in each of the piles. Yes?
How does it know that it's higher than the recognized overseas state order?
Because it's magic.
Okay.
It's actually doing a string.
Okay.
It seems a string, and if that string matches the next string, it says it's the same thing.
So the string is the word.
Yeah, if there's a spelling error in one of the rows for Canada, it'll make a different category. It's not that smart. It's smart, but not that smart. That's why you're here. Right? Yes. Absolutely. This is why this is awesome and it sucks. Because it was awesome that I could do this, but very quickly it got into the sucky part. How come some of the rows are Asia and Asia GCP? Is that the same thing? I gotta go figure that out. Oh shit, how come Canada's there and Canada lowercase is there? Shit, I combined those two. Because the first 50 years of Canadian data are one, and the other 50 years of Canada and another are lowercase, and they put it in different categories. If I try to just go and do a quick and dirty analysis, I'll get the wrong answers. So it's powerful, but then it also means you're gonna have to do the work to make it better. Okay?
So if one of the students does not have the right data spreadsheet, so how can she generate?
Because it's not the correct columns,
I guess so.
not because it doesn't have 31,000 rows.
Isha, can you reply to that?
Hello, yes, it's very similar. I get almost the same results, but like I feel maybe I just have a different spreadsheet.
okay, what I'll do is I can, I'm gonna take another pause in about 5 minutes. Why don't I get everybody going here? And I'll come back online and take a look at it with you with a screen share. Is that okay?
Okay, thanks.
Thanks.
So, okay, that's good. Yeah, I'll come back to get everybody at the same place in about 5 minutes. Okay. So dot value count, super powerful. Okay, so now, but the question was, does 31,000 rows make sense? Well, super approximate, 258 categories. Maybe a bunch of the categories are weird because they're not countries, like Europe isn't a country, South America isn't a country. Let's go 250. Let's say there's 250 countries. By the way, it doesn't make any sense. I think we know there's 160 countries, but in the world. But let's say there are 250 categories times what looks like a lot of the categories that show up 270 times. but some of them don't show up. But basically, if I do 250 times 250, what do I get? Anybody have a calculator? 250 times 250 is like 25 times 25, which is 625, but with an extra 2 zeros, so 62,000. 62,000 rows, what I would have expected if I had 250 countries, each represented 250 times. 60,000 rows, I only have 30,000 rows. At least I'm not in the millions, and I'm not in the hundreds. I'm in the right order of magnitude. I'm comfortable with saying this is not garbage data. Of course, we knew this was garbage data, it came from a super important source. But I'm comfortable with saying 30,000 rows probably makes some sense. That's super important, and we cannot automate that. That's you thinking, okay? Maybe ChatGPT could figure this out. Not sure. Right? If I said ChatGPT, does this data set make sense in terms of the rows? Maybe. Because, but that, I mean, you could also think about it as people and figure it out, and not have to have ChatGPT help us with that. But the point is, that's the kind of thinking I'm going to need you to do when you guys go start getting other data sets for your data storytelling problem. If the data I just got make any sense, count the number of categories, cover, try to make sense of that.
So does it make sense? I think so. I'll make a little comment. 258 entities times around 272 rows per entity is going to be roughly 62,000 rows, which is in same order of magnitude as 31K rows.
Don't write that down. This is just me making a mental note for myself. But you should make mental notes for yourself. You see something that's interesting, make a comment in your code cell so you can come back to it. The deeper you get into this game, coding, data analysis, whatever, you'll see that you'll have thoughts. And if you didn't write those thoughts down, you'll forget. So write the thoughts down.
All right, I took a little bit of detour on a question I did not plan on covering. Okay, how many rows? We answered that. How many years of data do we have for Canada? So I could probably find it in here. If I were to sort this and find Canada in there, I could, but I'm just going to show you how to do it a different way. So what I'm going to do,
I want to answer. Do I have 272 years of data for Canada? That's the country we're Canada. There's a lot of countries. I have 272 years of data for Canada. Well, first, what I want to do is I want to take that table and just get the rows that had Canada in and look at them. That's really what I want to do.
so what I'm going to do is I'm going to write DF. And then I'm going to write entity, because that's how I get entity.
Right? If I do that, I'm just going to get the row back. The column, sorry, I get the column back. I want to make it.
I only want those places.
So when I put a double equal sign in Python, not just in Pandas, but in Python, it's basically saying, is it equal? If I put one equal, it's not a question. Make it equal. DF equals PD.read CSV. Whatever comes out of PD.read CSV, make it into DF. And now they are the same. But if I put two equals, it's as if in your mind's eye, you have a little question mark here. Is it equal? Because if it is equal,
Something will happen.
if I just run that, I actually get another series back that has 31,000 rows. And what it did is it put trues or falses. You can't see it, but there are some trues in here. Most of the entries are false, but some of the entries are true. And it's only true where the entity is equal to the string Canada. It's not very helpful.
This is where we do what we call slicing. We're going to go to the front. We're going to write DF again. We're going to put a square bracket. What? No.
So that thing where this was the check. Is the entity equal to Canada? Well, you're asking that question 32,000 times, 31,000 times. But when you do this, it's like, Candace, can you please go in that column and go down that column, and every single time I want you to do a check. Is the value equal to Canada? False. Next. Is the value equal to Canada? No, false. Is it equal to Canada? False. Eventually it's going to say true. And then it'll say true again, and it'll say true again, and it'll say true again. Then it's going to say false and false and false. It's going to give you back the answers. It'll give you back 31,000 times true or false. So I want you to take that and put that as a filter, as a slice, and that's terminology of DF. If you run that cell, you will get a slice
Of the original data frame.
you will just get the spreadsheet, the table back, where the entity was equal to the string you asked for. This does not have 31,000 rows anymore.
How many rows does it have? Well, I could do dot shape, but if I just look down, Pandas does stuff for us. 237 rows. So we don't even have 272
Years of data for Canada, but we have 237 years of data. This kind of makes sense. First year in 1785, Canada had this many annual CO2 emissions. In 1786, in 1787, and it seems to go all the way down to
2021. We have the emissions data for 2021. Yeah?
They're not showing. It was 2005.
oh, great question. Okay, let's do it.
So this is awesome. I just got the piece I wanted. I just want Canada. When you get something awesome, save it. I won't call it Canada because maybe we'll change countries. So we'll call it DF of one particular country. So basically, don't print it. Save it.
Where did it go? I want to see it. Well, what happened was, the thing that just got printed here, I'm saving it into a new variable called DF country. And now we're going to go inspect that to answer your question.
So I'm going to poke, remember we were been poking at DF the whole time? Let's poke at DF country, this new data frame that only has 237,000 rows. DF country, let's just make sure. Yeah, okay. So now you said, well, I want the year 2005. So what I'm going to do is I want a particular
Location in this subtable. So location dot loc.
So dot loc square
So now I want a particular location. You have to think of this. You know, if you were doing if I said this to do this manually, you ask me a very particular question. I want the row where the entity was Canada, but the year was 2005. I've kind of already done the first thing. The year is Canada. But now I want where the year is 2005. So it's gonna have that same kind of structure where I want a particular check. In this subtable, I want the year to equal 2005. I put a comma, and what column do you want? I want the, and I have to, because of the subscript, I'm gonna. And now I got exactly how much emissions there were in 2005. I got the value back. Now, maybe you wanted to see it nicer. I wanted to see it printed out nicely. Why is it doing this? Well, it's because this is the I can programmatically, it's like you have, imagine a spreadsheet is like in front of you. You now have like this amazing laser pointer that can go and find any cell you want based on this kind of conditional slicing and logic. Okay? You can actually don't have to do it on DF country. You could have done this like this. If I want to go in DF. I have multiple conditions. I want the entity to equal Canada and I want the country to be year. So this is working on the original. DF was the original thing. I want you to put DF in front of me. I want you to do, here's my magic Canada's laser pointer, slicer. I want you to find where the entity column is equal to Canada and the, whoops, that's not good. Okay. I want the year to be 2005. And I get the same thing back. You can make these, this is the, remember, double equals is like, is it equal? So what you're saying is the entity equal to Canada? And is the year equal to 2005? Yes? Give me back that column. That's how you read that last little chunk. You can nail the value you want. This was you, and you hadn't done Pandas, and you were doing Excel, you'd have to do the filtering at the top. You guys have ever used Excel spreadsheets? You filter at the top, and then you say, okay, I want the country, I want to put that one, and I want that year, and you do the same thing. Or if you didn't have Excel, you just had a file in front of you, you'd be scanning, okay, Canada. Okay, so this is the Canada section, then you go over to 2005, and then you get the emissions. That process has been encapsulated in this command. Yeah.
Eliminate the column and you,
Get what we have.
if I eliminate it, I have to get a data frame out if I feel I not out like.
Yes. So basically, this is saying I want that particular column. And if you don't put anything after the comma, does it even run though? Oh yeah, it gives you it back as a micro data frame, a 1-row data frame.
And that's true because when I said after the comma, so this is the logical checks. So it's basically when you think of .loc, teaching you a new, I talked about .head, .sample, .tail, .columns, .shape, .value counts. Well, .loc, which is like your slicer, it allows you to slice the data any way you want it, get with a small thing back. .loc means square brackets, and it does something before the comma and after. Before the comma is what are the conditions that you want, for which rows do you want to keep, and after the comma is which columns do you want back. And so if you don't give it any columns, it'll give you all the columns back. If I give it a column name, it'll give you just that. That makes sense? This is, it might seem like I prefer just getting it all back. But sometimes, if you have 5,000 rows, which happens a lot of times, you have 74 rows, you just want the rows that you are interested in, the columns, the column. You can have you can have CO2 emissions, you can have population, you can have longitude, latitude, but I want just the CO2 emissions, it's important to put the column name. So yes, if you don't put the column name, it'll give you all the columns back. But before the comma in .loc is, which rows do you want? After the comma is which columns. Slicing. If you want to do a tutorial on it, Pandas is a great tutorial just on slicing. It's called, and I didn't make that up, they call it slicing the data. Pandas slicing. How do I take a data set and just get the subset I want? Yeah. Which rows is before the comma, and after the comma is which columns. And it's a little counterintuitive because if you don't put anything after the comma, it'll give you all the columns. Or I guess you could say, well, it's not that, but it'll give you all. Yes.
I was wondering if you want all the years, to see all the years, with Canada, how can you do that?
Well, don't slice it as much.
Right? You have too many conditions here. And you're back to that. Does that make sense? We had added a check to get the year 2005.
But if you take the check away, it'll give you all the years for Canada. Yeah.
So let's say you're like, I want to see the ones in the middle. First of all, the reason you don't see them in the printout is because of the screen size. Okay, but here's another one that a lot of people, I've been doing this for a long time. And so now I've seen where the true value is. I could do a different check. I'm a hippie, and I'm interested in the 60s. Not equal to 2005, but dot is in. (2000) 1960, 1961, 1962, 1963. Unhappy. This is a little advanced, and because it's advanced, I'm messing it up. So you can slice it by saying, I don't want necessarily something equal to something, but I want it to be one of these things.
So what this is saying is .loc. .loc is my slicer. Before the comma is which rows, after the comma is which columns. Before the comma, which rows? I want the rows where entity was Canada, but the year is in one of these years. And I just get 60s. Okay, so you can really slice a lot of different ways. I just want every 5th year. I just want all the beginnings of every decade. I just want all the countries in Europe. I'm not going to do it, but you can do all of that. I just want all countries south of the equator for every leap year. You can do all of that with the conditions up front. And then after the comma, put which columns you want back. If you don't put anything, you'll get all the columns back. Yeah? Yeah, but that's like Python gymnastics that I can show you after. That's great. But then, yes, absolutely. You could say Python calculate for me, and I don't want to write it out. But Python, that's not Pandas. Python will generate that list for me if I know how to do it in Python. And then I could call that list. I can make a list of every second year between 1850 and 1875 in Python, because that's just Python gymnastics. Take that list, save it, and then in .is in, put that variable there, it'll do exactly. And the reason I'm saying it is because it's important to parse out what's Python gymnastics and what's pandas. Making that list of fancy years or countries that have the fourth letter L, whatever stupid condition you want to come up with, you would do that in Python. But then dot is in, double equals, dot log, dot value counts, those are pandas. Yes.
If I want to do the other way around, like something that's Canada and then let's say Canada and Sudan.
Good questions. I'll never finish.
I'll never finish. I want every country except for Canada. So you put the tilde. That's the logical not in Python. And now I got every country except for Canada for those years. So it was this little, in Python, that's called the not operator.
So you gave me a bunch of trues or falses for entity equals Canada. Whatever was true, call it false. Whatever was false, call it true. And then give me those rules back. Great question. The not operator. That's a Python thing being inserted into the pandas loc command. Okay. Yeah.
So the square brackets falls on everything in the data.
Yeah.
Only values.
Yeah, exactly. The square bracket allows me to look inside df. Dot loc allows me to get conditional checks and certain columns back.
Good. What was the question? How many years? I think we answered that question. So we're good. We answered that question. On average, which country emits the greatest amount of emissions? So let's go here. Oof.
Okay. I want to calculate the average amount of emissions for each country. Sometimes when you're asked this kind of question, and you're thinking about this kind of question, you have to say, well, how would I do this in my own, if I didn't have a computer? We were back before the age of computers, and we had a piece of paper that had 30,000 rows in it. You would have to take all of Canada and calculate the average for its emissions. Then I would have to group the data, and for each group do something. Okay? Now, first,
Something like calculate the average is also just available on its own. The question could have been, get me, sorry, you always have to copy paste the name of this particular column.
so if I write dot mean on a column, so df annual CO2 emissions dot mean. Mean is the geeky way of saying average. Average means a measure of central tendency. Roughly, how much emissions are we talking about? Because there's a lot of values of emissions. But the thing is, that did the average of all of my data. I want that average for each category. There was 250 categories. So I want you to calculate the average 250 times. So I want to group the data before calculating the average.
So that's why it's as simple as that. Go to DF, do dot group by.
Before you go and calculate the average of the CO2 column, group the data by, what do you think I'm going to put in here?
Entity.
And what it did was it calculated the, so what it did was DF got grouped by, took the DF and went to the entity column and got each packet, each category, and made little subsets. Did that fast. It took those 31,000, the whole data frame, and made 258 types of data sets. And for each one of them, went to that column, calculated the average, and put it up in. And it's sorted for you by the highest average to the lowest average. Right? So Afghanistan. Oh no, sorry, it sorted it by the country, by the entity. If you want to know what the greatest emitter over time is, now
On this, do dot sort values, because it's sorted on the index. Oops, no, that's not gonna like it. It's got to be sort values, not sort index. I showed you sort values, but sort index before. But sort values. And well, the world is the greatest emitter. Tuvalu is the Antarctica.
these are the small emitters. Antarctica is not a big emitter, so this is in ascending order. And this country, its average was about 1,000 kilotons of CO2. The world overall is 6 billion CO2. Yes.
And what if I want to get rid of all those like not big countries, but like the things that aren't actually countries, how do I do that?
You're gonna write those the names of the categories you don't want. And then you're gonna do not DF entity is in the things you don't want.
There's no other way to do it faster, it doesn't be forever, no?
Yeah. So part of you is like, this sucks, I want my money back. What I'm trying to tell you is you wouldn't even know you didn't have this in front of you, right? This gets us the place to be able to say, this is what has to get done. These are the questions that matter. And sometimes it points out questions or processes or solutions that you have to do and they suck. It sucks. You're gonna have to go and figure out which of the things I don't want. And how are you gonna know I don't want them? I don't know, you're gonna have to think about it. Maybe what you're gonna do is you're gonna go find another data set that gives me the list of countries only, not weird categories. Maybe if I found that as a table, and then if I could figure out how to do some kind of check between entity, if that entity is in this list of countries that was generated by Wikipedia, which is the list of countries of the United Nations, let's say. Now we're in money. Right? So if you're smart about it, you can get it to do it with dot is in. Is this dot is in? Did you make it yourself because you manually went and looked? Or did you say dot is in some other data and got exactly what I wanted? Yes.
So we can cross-reference other like different types of data.
That's my point. Yes. I slowed down a little bit. I went a little slow, but that's the most important thing I'm going to show you today. Because true data journalism is not interesting if it's on one data set. One data set, anybody who comes to Samir's tutorial can do that after a couple hours. Two data sets requires human intelligence saying what that other data set should be. You should all, like right now, we're going to do it. Watch.
First of all, I just showed you how to get, what was the question? On average, which country emits the greatest amount of emissions? Okay, this is annoying. So you're right. So here, let's do it. We're going to do exactly what you said we're going to do. I'm going to make a little list of who I think are the greatest perpetrators. My guess is Canada's in there, United States, United Kingdom. How do I know those are the correct strings? Because I was practicing this presentation for about a while now. France, I hope France is spelled like that in the data. Put China in there. Oops. We'll put India in there. Let's put Australia. I hope it's spelled as Australia. Give me some other G7s or big Brazil, big country. Let's put Brazil in there. Russia's complicated when, especially with the fall of the Soviet Union, but these are the complicated questions. Let's start with that. You can make a list of countries. So in Python, a list is anything in square brackets. Okay, so when I write countries equals and I write those out, I'm making a list of strings. Okay, sometimes it's nicer in formatting because Python's very friendly with spaces sometimes and sometimes not, but I like doing this so I can see it better. Yes, but the problem, what you can see here, is I wasn't really interested in Tuvalu or Antarctica. That's a great, you guess, we actually, it already did it, and I could have flipped it, but I'm kind of stuck where like the biggest ones aren't countries, and the smallest ones aren't what I'm interested in, right? So I'm going to try to define which ones I'm interested in from the beginning. We're talking about CO2 emissions. We know who the big perpetrators in the world are because we live in this world. This data is very, so this is where we start getting at, the computer won't have the answers. You have to do these kind of slicing and say, you know what? I want these particular countries. Why these particular countries? Well, because I think they're in the news most. Okay? And I'm going to slice it first. So you see, before you group anything, do a slice. Slicing, if you only are slicing the rows, you don't need dot loc. Remember I said if you want to slice, you put dot loc. But if you don't care about, you want all the columns back, you could put dot loc, comma, nothing, but you can also just go straight square bracket. So df, just meet this condition. So I'll even do this to make it clearer. So df square bracket. So that square and that square. This is going to slice df based on this condition. I want the entity to only be in that list of countries. And on that thing that comes back, do a group by entity and do the emissions for those. And sort that on values. There we go. Okay, and now only those countries popped up, and I have their average emissions over all time, and we knew this. China and the United States are the greatest emitters. Australia, smallest emitter by almost a factor of 200, 2 powers of 10. Right? This is 2 times 10 to the 9. This is 6.9 times 10 to the 7. So 2 powers of 10. Australia emits somewhere 2 orders of magnitude less than China and Australia. China are on their own. Russia. Problem is, this did not check if was this the same number of years included in each country. Right? It's not necessarily a fair calculation. Imagine that for Russia we only have certain years because it used to be called something else before. It used to be called the USSR. So we have to go look at the data and see, okay, is there a USSR entry? So shit, we should map that. Or is it the same because USSR was bigger than Russia? This is that's where we need your brains. Any trained monkey could get good at PANDAS. We need your minds, your thinking to say, okay, but now I have to think about this. Russia was not called Russia. And what would be a fair comparison to China, which has always been China? The United States, it's been the United States since United States was 1716, whatever year the United States was founded, was it the same entity the whole time?
Those kinds of questions are at the heart of a true data analysis. And it's messy. Okay.
Okay, I want to do about 5 minutes and then I want to pass it off to Vanessa, and then we'll come back and do more pandas before we really launch you maybe into the thing. Yes.
Will you show us how to turn that into a nice data frame with the headers as well? Like the next table? Say, like a table that has just the entity and the. I can show you that right now.
Because this is a series. Actually here. But what if I don't want the mean, I want the median? Well, don't write mean, write median. So now you have the middle value of emissions over time for each country, not the average. Okay, and this is a different discussion. What's the difference? What's the benefit of using median versus mean?
Mean can be thrown, your average. You guys have grades for quizzes, you know this, right? Your average is thrown off by outliers. If you're typically getting 70, 72 in all your quizzes, and then all of a sudden you get 100 on one, well, that will throw off the mean, the average, but will not throw off the median, which is just the middle value it's lined up. So median, you can get that, but you're like, oh my God, this is a lot of thinking. I want all the stats.
I want all the stats. This is why I love what I do. Describe. This won't work. Holy shit, it worked.
Give me all the stats. I want you to see how much just happened. DF. Square bracket, okay, slice. Just give me the subset that has the countries that I'm interested in. Group it by country, so make a bunch of little data sets. Get that column and give me all the stats on that column for each of the micro data sets. So Australia shows up 272 times. We know now means 272 years of data. The average emissions is that number. The standard deviation is that number, because that gives you the spread, because it could be, you have a lot of spread over it, or it could be the same value over and over and over again. It'll give you the minimum number of emissions, the maximum number of emissions, and all the quartiles. For those of you who know more stats, we're not going to get into what the quartiles are. Give me all the stats as a data frame like you just asked for. So not only did I give you a data frame, I gave you lots more stuff in that data frame, and it's for all the countries I was interested in, just those countries. Okay, if I asked a monkey to do this, or not a monkey, but someone from 1800 to do this before computers, this, you have to think what the operation is. That's super valuable when you're trying to chain these pandas commands together. First, slice, then group, then pick a column, then do something. You could have just brought .mean to do one statistical function. You could do .median to get another statistical function. You could do .standard deviation to get another statistical function. But just do .describe and get them all back at the same time. Okay?
All right. Does that answer my question to start? Yes. And what was the last question? In what year does the US have its peak of CO2 emissions? I'm going to leave that one on for a second because I do want to, I think I've been going for a while. I want to make sure people are caught up and in the right place. Instead of answering that last question, I want to just show you the first part of visualize. Because visualize in this next portion, which I'm going to get deeper into, so I'm kind of changing the plan a little bit on the fly. I want to make sure that Vanessa gives you guys the framing examples. Okay, framing means how do I think about telling a story based on data? Okay, so Vanessa's going to take over and talk about that. But I haven't really told any stories yet. I've given you some tools where I think you guys can start answering interesting questions. Like, did the year that when everything started going up is also when population came into account? Population started growing in the 50s after the war. Does that line up with when we have more emissions? How does wealth come into play? I want to give you a bit more tools and that big question that I said, how do I combine this with another data set like wealth or population? I have to show you that still.
And I thought I would be done way further by now, but I'm not. It's okay. Point is, I'm gonna show you how to do that. I want to pass the mic to Vanessa in a second. I do want to tell you though, to do those kinds of things, you really do want to visualize the data. To visualize the data, I typically use other packages like Seaborn and Matplotlib, which I'll show you how to do. And now seems completely ridiculous to say that I can do all of it inside the first 2 hours. But nonetheless, I'm going to come back at 1 o'clock. Instead of just letting you off into your data journalism challenge at 1 o'clock, I'm going to steal an hour and do visualization from 1 to 2, or whatever lunch, whatever we talk about. And then I will send you off with the actual challenge. You'll be a bit more equipped for the challenge. But Pandas is so good that it's already hooked into the visuals.
So let me tell you what I mean by that. Let me show you how Pandas can give you visuals without you getting into Seaborn and Matplotlib, which are the visualization part. DF entity dot is in countries. I just want those countries for now. Okay. And I'm going to do a dot loc because I really want one particular column. I want the annual. I always have to copy paste that column name because of the subscript. No, first of all, let's see what that gives us. Okay, so this gave me. No, this is not, sorry. I just want to give you a little bit of like, can we have something more fun than just doing little slicing and dicing? Can I get a picture? I don't want to leave you guys hanging without even a single picture after all this time. First of all, let's get just the countries we're interested in. Okay. I'm going to call this DF for a plot. I want to make a plot.
Okay, before I pass the mic off, because she's going to be talking about visualization, we haven't done any visualization. I want to give you a quick thing that you guys could make an interesting graph if you know Pandas well enough. You don't have to know anything else.
So save just that in DF plot. I don't remember if this is going to work. Let's just try it. I want a group for every country. It's going to watch. Sorry, this I didn't. I'm going to see my pants here. I don't know what that's going to do. Well, that doesn't make much sense, does it? Anyway, what I did was I just got the subset of the data, which is the countries I was interested in, and I called it DF plot, which is the data I want to plot. Okay. And I thought I could just get an individual plot for each of my countries over time. Turns out that didn't work. But I'm just trying to tell you, sometimes it works out really nicely. You know what? Okay, you know what we'll do? Here. Maybe this will work. Okay, that's no good. Let's do this. I don't want to get into Seaborn because normally I would use Seaborn and Matplotlib to get you a picture, but I want to do it straight out of here with dot plot. Let's do it for a couple of countries. Just a couple of years. The year dot is in. Oh, you know what we'll do? Greater than, equal to 2000. No, 2015. Let's do it for the last 5 years for each of those countries. There. Look at that.
Doesn't matter what you're looking at. I'll show you what you're looking at in a second. But look, I didn't even have to go into another library. Pandas, I'm just trying to tell you that sometimes if you're working with a nice small enough data set, you don't even have to know any other libraries. That data set, just call dot plot on it, tell what kind of plot you want, and it'll give you it. God knows what we're looking at. Let's try to see what we're looking at. I'm seeing a bunch of countries. Each of the countries got a bar.
What is it? It must be emissions. That is the thing that I'm plotting. Oh, anyone want to take a shot at what is it that you're looking at there? Looking at what I wrote,
Can you figure out what is the graph? Yes.
So it is ranking the countries on a proportion of like China's mean CO2 emissions. So
Overall time.
overall time, so it's saying.
Sorry, over the last 6 years.
Oh, yeah, sorry.
Great, absolutely. You are visualizing the average, dot mean, of each country over those years, because I only kept 5 years. In fact, I guess I didn't even need to do that.
I could have just or let's do, because it's not fair to compare it to 1700s with now. But let's say since the year 2000, which country has been producing the most emissions?
And you already got a plot. You already have a story to tell. You can start telling the story. This has no time analysis in it yet, does not take into account population, does not take into account wealth, history, nothing, but at least you got a picture. So now that I've given you a taste of that you can create a picture, I'd like to pass it off to Vanessa so she can tell you what to think about before you start making pictures. Because look, one line, I got a picture. I must be super powered now. I can make any picture I want. What kind of infographic, what kind of graph is valuable, is going to tell you something, and how should you think about the type of graph you want? You should always make the graph you want on paper by hand before you ever try to do it on the computer, because you'll be spinning your wheels not knowing, am I taking the average of that and combining with this, whatever. Think about the graph you want to make first. What I did here was ass backwards. You never just make a graph and hope it tells a story. Do the other way around. You say, what story do you want to tell? And then try to make the graph. What I should have said is, I want to know, I want a visual of which countries are the biggest emitters. I want a visual representation. And then make this. All right. You want to, is it good?
Stop share for a second. Your USB?
Better, or do you want my Dropbox?
Let's do this so you don't have to put your password on my stuff. So I don't want to mess up your accounts.
I'm coming at this from a social science perspective. For someone like me, I know that the numbers are probably saying to you, those of you who are, or I imagine it in my head, right? The people like me, it's like, oh wow, so here just spent like 3 hours making more numbers out of numbers in my. Okay, so I am your average person, and your average person has no idea what the numbers are saying. So, you know, for people like you who understand numbers, the trick is to make those numbers speak to your average person, and this is going to be really important as we move forward into what we now know as the climate crisis. Okay. Oh, very good.
Which one?
We're going to start with taxonomy of story. Okay.
I'll be the,
So how do you talk to your normal person who, like me, looks at numbers and gets a headache, okay? You have to start by taking these data sets and figuring out what's relevant, or how you can use the data to actually explain what's going on to your average person, okay?
So where can we share the screen?
Oh, shoot, sorry.
Yes, absolutely.
Not that one.
Oh, no, this one.
Not that one. Yeah.
Is that good?
Right? So it's not just about science. It becomes about communication. It becomes about art. It's about making data easier to understand and use, shaping understanding, clarifying meaning. We use stories to illustrate complexity, show the relationship between ideas. We need a snapshot of changing systems. I'm going to go through this really quick because I realize that the analysis part takes a lot of time. And I can run through this super quick. You'll have access to my presentation to help you out as you're doing your stuff, okay? What's important is to be clear, all right? Make complex information easier to understand. Make it compelling. How do you grab the public's attention moving forward to help them understand their new realities? I'm going to start with this data visualization of births. This is births in the United States. What you see here is a birthing boom, all right, between 8 and 9 a.m. Because this is where the doctors come in to do the C-sections, all right? There's also a boom after lunch because that's when doctors are available. Now, for someone who's given birth, you're going to have opinions about this, but the reason why I sort of show it to you is that it's beautiful. And also, I really think this is a nice way to kick off because when we're talking about the climate movement, the labor that we do are for future generations, right? I do this labor, like the climate problem is probably not going to affect me too much in my lifetime. It's going to affect my children. It's going to affect my children's children. It's going to affect you more than me, all right? So that's something to sort of bear in mind when talking about climate issues. Okay, data visualizations are nothing new, right? This is something that was done when 1859. Physician John Snow. There was a cholera outbreak in London, and what this guy did is he went door to door to door and spoke to people. And every time there was a case of cholera in a house, he mapped it out. And he mapped it out. And he mapped it out. This was ginormous. All right. And then over time, he realized that there was like a preponderance of cases really right around this pump. It was a water pump. And he was like, could it be that cholera, because at the time they had no idea, cholera comes from contaminated water. He got the city to shut down the pump, and sure enough, the cholera outbreak came to a close. And this is when they understood that cholera was about water contamination. Okay, pretty awesome. He may have, oops, went wrong way. He may have been, is there a way to make this nicer?
I had to go back to this mode
Okay,
because on Zoom, when you're in slideshow, it was not showing, it wasn't following along.
all right.
So it's, I have it in this mode, apparently, here it is following. So if you just go down the
Oh,
slide.
good. That's fine. Okay, so this is Florence Nightingale. Okay, if you've heard of her, you've heard that she's like the founder of modern nursing. I think she's more than a nurse. I think she's a bit of a genius, and she's a mathematician, right? And she graphed things out. And what is this data? This is her, she was sent to Turkey to basically try to help soldiers of the Crimean War who were injured. And she went to this hospital, and she was sort of observing, you know, what was going on. And she realized, this was the Scutari hospital in Turkey. She realized they weren't dying of their injuries. They were dying of like infections, right? There was something wrong with the hospital. The hospital was really dirty. Now, this wasn't really a thing back then. But she started to document how soldiers were dying. And so she made this data visualization. She sent it back to the Times of London, who published it in their newspaper. And the British government responded by sending out a prefabricated hospital to Turkey.
And this new hospital called Scutari brought down the death rate 10 times. All right. At that time, she was also like, you know what, maybe it's a good idea that we start washing our hands between treating patients. Right. So she was like the first person to really look, well, not the first person, I'm sure, but the first person to really look at data hygiene and talk about it, or hygiene, sorry, and talk about it in data and educate people about the importance of hygiene in hospitals. Okay. So you have to ask yourself, you want to influence people. Who are the people you want to influence? What do you want them to do? And this might be intimidating to you because you've just been trying to grapple with how do you sort of manage to get like whatever information out of data sets, but you have to start at the beginning, and this is the beginning. You don't have to have the answers right now. Sometimes the answers come from the data as you manipulate them, but bear this in mind and refer back to it as you're doing your work. So what kind of story do you want to draw from the data, and what's the best way to illustrate your story? This is what we're going to talk about now. Okay. There are several things that you can do. You can look at changes over time, interesting factoids, what I call interesting factoids, surprising connections, personal experiences, revealing comparisons. It's not a comprehensive list by any means, but it's a really good start. Okay. Changes over time. Humans experience the world through time, so before and after stories are relatable. How do you take this data, this is temperature data, from one point in British Columbia in 1950, whatever, 1959, how do you express to people how the temperature has been changing over time? There's so many interesting ways to do it. This is a really gorgeous data visualization by climatologist Ed Hawkins at University of Reading in England. So there's a progression from blue, colder, to red for warmer. All right. And these are the global average Earth temperatures from 1850 to 2018. He used data produced by the World Meteorological Organization. You can superimpose another graph over it. Conventional line graph. And it illustrates year by year the correlation of data points in colored stripes. This is another way to do it. He did this. Sometimes it takes a little time to start up. This is a GIF. Again, it's about the change in average global temperatures. And hopefully it starts. Come on. Usually it starts. I can't get it to start. Okay, but this is a spiral. So it starts at like, you know, the lowest temperatures and it spirals out, okay, over time. You can choose to do that. Okay, I don't know why it's not, it's probably because it's not in presentation mode. That's fine. Okay, next. So this is another one. Okay, it's a, yeah, that's fine. I got it. Okay, so this data visualization takes basically the average. This is by Antti Lipponen. He used NASA Land Ocean Index data to track the annual average of temperature anomalies across a wide number of countries. Okay, and so every year where you have anomalies, there you have it displayed by like the size of the circle. And so when it starts, there are very few anomalies, and as it goes year by year, you get bigger and bigger anomalies. It's a shame that we can't get it to work, but in any case, that is something. And yeah, you want to see if you can try it? There you go. Okay. Right, you can do something like this and it shows the general public quite visually, right? How temperature anomalies are evolving over time. Okay, this is on the loop, by the way. Okay,
Was this one? Let's just see if
Yeah.
I can do it.
okay, so this is the spiral. This one takes a little bit. This is another way of showing the public how temperatures are increasing over time. Okay. I have another one. Okay, I don't have a lot of these animated ones, but the ones I have, this is worth showing. This here goes a bit quick for my taste. But it illustrates our climate budget. How much do we have left before we warm the earth to more than 1.5 degrees? Okay. So you can consider these sort of animated GIFs. Hopefully yours are going to be a little bit slower. Okay. So the next kind of sort of thing that you might consider doing with your data sets is looking at the anomalies. Okay. What are the interesting things that sort of pop out at you? Okay. Usually when we look at data, we're looking at the aggregate. We're looking for patterns in that. We don't usually like focus on the anomalies, but sometimes that's where some of the most interesting stories are. This is a data set of trees on public property on the island of Montreal. There's one lone Kentucky coffee tree. What is a Kentucky coffee tree and why is it there? Long story short, this is an endangered plant. I don't know how it got there. Usually it needs a floodplain in order to live. So whichever homes are around there, they might want to check their foundation walls. Also, if it hasn't been done, it should be signaled to the government. It would be really illegal to harm this tree. All right. Here's a data set of climate emissions by industry. If you drill down, what are the anomalies? Can you explain them? This is Google searches of puppy. Okay, there are spikes at the beginning of every year. So this might indicate that people sort of look for puppies when they're doing their New Year's resolutions. They might be considering buying one. Anyway, this is an example of a story that you can do with anomalies. This is a really great one. This is a carbon catalog of consumer goods by Christoph Meinrichen of Columbia University, published in Nature Journal. Researchers at his company Cochlear used data from the CDP, which was formerly known as the Carbon Disclosure Project, to come up with this visualization. Okay, so their research found that 20% of companies who pursue carbon reduction in 2016, 2017 did so specifically after receiving data requests from supply chain partners who were already reporting their carbon emissions. So even just by making data public, companies are pressuring each other to find ways to reduce carbon emissions. Okay, that's really interesting. So the next thing you can do is look at personal experiences, which, by the way, isn't about pulling personal experiences, making stories from personal experiences. Okay, it's about pulling personal experience stories from data. Okay, it's two different. Sorry. Okay, I'm gonna move on. Okay, you're paying attention. I see. I got a couple of laughs. Okay, great. This is blank. Okay, this is blank because something is missing. Okay, so what's missing here is anyway a headline about how Montreal's outdoor skating rinks are in danger, right? So if you think that climate change isn't affecting you, ask yourself how many times you went out skating this winter, okay? And anyone who wants to talk about how the climate crisis is affecting their life here in Montreal could definitely look at the city's temperature data and compare it to the temperature range required to make ice outdoors skatable, okay? And in this way, you can determine the number of days this winter that public rinks were usable. This here was Alain Robichaud and Paul Comtois. They tracked asthma hospitalization in relation to Montreal's pollen count and temperature for a journal called Air Quality, Atmosphere and Health. Okay, so if you have asthma or if you have allergies, definitely interesting to track hospitalization rates as temperatures increase. Next thing is about surprising connections, okay? This is about correlations. Note that correlations is not causation, so take it with a huge grain of salt. This is a really nice diagram of how the number of people who drown by falling into a pool coincide quite neatly with the films Nicolas Cage has appeared in, okay? You can definitely find ways to come up with these crazy graphs. And okay, we do want to look at how things sort of change, all right? And at the same time, but this won't necessarily show you if one causes another, okay? There is a near linear relationship between carbon emissions and global warming. So you can definitely, people can definitely find all sorts of ways to graph that. Urban emissions and urban income correlate, okay? So the more money you have, the more you emit carbon, surprise, surprise. You can graph that. This data visualization takes a look at how climate change, the urban areas most impacted by climate change are also the ones that have the highest growth of population. Okay, so that just means that over time, for more people, this is going to become a bigger issue. Okay. There are all sorts of ways to do data visualization. Some of the best data infographics explore the correlation between global warming and other natural phenomena. This was put out by the World Wildlife Federation. This one's particularly beautiful, and I'm using this to come up to explain the last type of story, which is comparisons, right? When you compare different slices of data. This gorgeous data visualization was created by Frederica Fragapani from Milan, and it compares China, New Zealand, and Canada's carbon emissions over time. So the left-hand pedal starts at 1992, and it sort of goes. And then the blue petals represent where carbon emissions actually declined relative to the previous year. And you can see each of the graphics just sort of depicts by area, right? The comparison of carbon emissions. New Zealand, small country, small population, although it's rich, overall it doesn't emit the same. Canada, bit of a bigger country, again, with New Zealand trying to use renewables, and China, of course, a country that's booming. Yeah.
Yeah, I was wondering, in the previous graph, you said the more money that you have is related to the more city. How would we know that it's not a correlation? It's correlation with that. How are you able?
Yeah, absolutely. Okay, so basically, the graph, the previous graph, okay,
Took carbon emissions, this one, okay?
carbon emissions per capita, all right? So basically, it's a graph of carbon emissions per person, all right? And it compared, and it's just saying, I mean, it could be that the more you emit, the richer you get. Okay, or it could be the richer you get, the more you emit, or maybe it's just a coincidence. Right? It doesn't necessarily prove causation, but it does show, right? For whatever reason, countries that are wealthier will, those people per capita will emit more carbon. It's not up to interpretation. I think it's just, what is the message you're trying to put out? Right? Does it matter what causes what? Is all we need to know the fact that there's a link between consumption and carbon, and we need to figure that out. Maybe that's enough. Okay? You always have to bear in mind what your purpose is. Okay? Are we good?
Okay. So this is, again, COP meetings, okay? As Samir mentioned earlier, COP stands for Conference of the Parties. And this is the decision-making body of the United Nations Convention on Climate Change. And it shows how over time, the conversation about adaptation and mitigation has really come to dominate the meetings, okay? This is a graphic of countries that are affected by climate change. A graphic of those most vulnerable to climate change. And this is the graphic of countries that get most aid to help them with climate change, all right? So here we're just looking at where the money is going to help the countries that need it most, and is that actually happening? This was produced by Milan Politecnico. This here is a comparison between money pledged to help countries mitigate climate change damage and what was actually dispersed. Again, produced by Milan Politecnico. So the question is, can you find stories of change over time? Can you find interesting factoids? Are there surprising connections? Does personal experience make certain parts of the data more relevant? And are there contrasts in the data? Okay. The next step after this is for you to understand how to select the right visualization for each of your stories. Are we good? Okay. Do we have time to do that?
Yeah.
Okay.
What the other one?
This is a training marathon. No, just kidding. There's a lot to say.
This one? How not?
Nope. It's one that's called Taxonomy of Techniques.
I'll leave it like
Yeah. Oh yeah, okay. Is that it? Yep, okay. So there are a tool belts of techniques that you can use when getting stories out of data set. When you've decided what story you want to choose, you're gonna have to figure out how you're gonna make it look, all right, to the public. What are the visualizations gonna look like? So there are specific visualizations appropriate to personal stories. There are traditional charts, creative charts, data sculptures, traditional maps, creative maps, and you can actually be the data. This is immersive analytics, okay? I'm going to introduce you to that. So when done well, data representations make a point and they drive change. This balloon represents the amount of air pollution put out by a car in one day, okay? Placed in front of the Beijing climate talks, it sought to create a public spectacle with this physical representation of data. Okay. Oops. The next graphic disappeared. I don't know why. Okay. Picture the map of Brazil. Okay. Does anybody know what the map of Brazil looks like? Yeah. So what's the background? What color? Anybody know off the top of their heads? Green. Huh? It's blue? I think it's blue. Yeah. No. Green. The background is green.
Flag.
Yeah, the flag. You guys can pull up the flag of Brazil on your computer. Maybe that'll be easier. Okay, the background is green. There's a diamond on it that's yellow. There's a blue globe and there are white stars, right? If you Bring up, yeah. It's not showing on Zoom.
Oh, okay, this presentation isn't showing on Zoom. Thank you. Hang on.
Oh, right, sorry.
It's okay.
Share that. I'll do that.
Okay. Ay, ay. Somebody,
So those of you on Zoom, you get to see the presentation where the data image fell off anyway. Awesome. Okay. So picture a flag of Brazil, okay? Anyway, so the background is green, okay? And this was in 2016. The green represents people living on less than $10 a week, okay? The yellow, which is the yellow diamond in the middle of the green background, represents people living on less than $100 a week. The blue globe in the middle represents people, or month, sorry. Let's see, $10 a month, $100 a month. The globe represents people living on less than $1,000 a month. And then the little stars in the middle represents people living
on more than $100,000 a month. Okay. So anyway, if you take up the picture of the map of Brazil and you use the legend, then you can see you'll never forget the figures, unless you're like me and you get week and months mixed up. Okay. So you can do that with national flags. Okay. Personal stories.
So here it's supposed to be a photo, okay? And it took place in a hospital, and there were data points. One photo can sometimes represent a bunch of data points. And the hospital in question was running a campaign to make healthy choices the easy choice. And they brought various departments together to brainstorm ways to do that. And their bosses sent people who weren't interested anyway to this presentation. And the organizers sort of put up a picture, and you picture it. And there's like a pamphlets place where you have pamphlets about how to maintain your health. And then next to it, there's like an ice cream vending machine, you know, the ones that sell popsicles and whatever. And then the people, you know, at this meeting were like, okay, picture this. Now, this is on the 3rd floor of your hospital, right? You know, think about, if you're going to talk about how we're going to sort of increase health and make that easier for people, let's talk about how hard it is to actually access food that isn't junk at the hospital, right? So sometimes even just one single photo can really be very impactful when it comes to sort of explaining data. Traditional charts, everybody's used to seeing these, okay? They can illustrate banal realities that we don't think about. This chart shows water consumption in the city of Edmonton. The vertical axis is the amount of water used. The horizontal shows the time of day. The green line is a normal day. The blue line is the day of the 2010 Olympic gold medal hockey final, where Canada was playing the US national team. So what you're looking at is between periods, everybody running to go to the bathroom. Okay, everybody's toilets flushed at the same time at these different times. And so this is a really cute graphic, and it really raised the profile of like the water utility company that really nobody ever paid attention to, because this cute little graphic went viral, right? And it just showed people, you know, how these big events influence how we use things like water. Okay, kind of interesting. So different traditional graphs, there are so many of them, and I could spend another 2 hours explaining which ones go for what. But if you want to look it up, I would definitely recommend going to Severino Rebecca's data visualization catalog, datavizcatalog.com. And here, if you look, you'll see what are the best sort of graphs to use to compare things. What are the best graphs for proportions, relationships, hierarchy, okay, and so on. So
his website you can refer to if you need inspiration. Okay. So creative charts is the next thing to sort of consider using. Okay, creative charts use the visual language of charts, but it adds visuals. Okay, this visual language includes lines, symbols, text bars, and so on. It'll let you break the rules of a chart to make something that is visually more appealing. Okay, this was produced by California's Good Institute, and it just looks at the amount of water required for different things. And as you can see here, beef is like a monster when it comes to water consumption. Okay. This is another example of a creative chart. It was put together by Washington's Brookings Institute and used data from the International Panel on Climate Change's Fifth Assessment Report. It's just looking at climate emissions by industry, by sector. So this next one is super fun. These are data sculptures. Okay, so again, the image disappeared. Picture a bottle of Coke without the Coke, but replaced with sugar in the bottle. So the bottle is about a quarter of the way filled with sugar. And that is the amount of sugar that is actually found in a bottle of Coke, but like dissolved, right? So you can externalize data onto a 3-dimensional form, and this is incredibly impactful, okay? You can hand it to others, react to it, use it as an object to think with, okay? Yeah. Hopefully the next ones are visible. Okay. So this is a sculpture by Janet Eckelman. It's called Earth Time 1.8. It's actually a video. I don't know if it, you can actually play it. This sculpture is up in the air and it's floating, okay? And it's called 1.8 because that's the length of time in microseconds that the Earth's day was shortened as a result of the 2011 earthquake and tsunami that emanated from Japan. And so the sculpture was made from the data sets of the tsunami's wavelengths rippling across the entire Pacific Ocean. This is pretty amazing. This stretches like over like a city intersection. So people were walking beneath it and it was just recreating, right? The tsunami waves in the Pacific Ocean. This sculpture by Natalie Maybach depicts weather and ocean data over a 2-year period from Herring Cove Beach in Cape Cod. She has like, this is her specialty. She has like an entire collection of data sculptures of this kind. Next is traditional maps. So it graphs data specific to geographical areas. I don't think that you guys are going to be doing sculptures and maps this time around, but you might want to consider it, and some of the more intrepid of you might be inspired. I don't know, we'll see. Okay, this represents data on geography of the planet in some way. Okay. Agricultural yields. Creative maps are kind of interesting. Yep.
Ask for the name of the artist who does the tsunami wave visualization. Excuse me, what's the name of the artist who does the tsunami waves? Now these presentations will be available to you, so you have it's Janet Eckelman, ECHELMAN. Yeah. Creative maps include cartograms where objects on the map are rescaled to change their size based on the data. So a creative map uses visual language of maps, but it does break some rules. This is a horizonless projection map that helps project dense cities. It puts the viewer simultaneously in the city, like you're standing here, you're in the city, and above it. The ability to be in a city and see through it has many uses, especially in gaming. I don't know, those of you who do gaming, you may have seen this kind of map before. Yeah, not. Anyway, pretty interesting. No? Yes, no?
Okay, this is another type of creative map. It's a cartogram of per capita national carbon emissions produced by the University of Sheffield's cartogram project. Okay. Okay, the next is immersive analytics. This I found really fun. I mean, if any of you could pull this off, I would love it. Well, and this particular example made me giggle. So what happened was they asked people to cut up a length of ribbon, okay, and the ribbon sort of had increments where they were measuring how much money you would need to retire. And so, you know, people were told, cut the ribbon, like the ribbon had like different measurements on it, you know, like for money. Cut the ribbon at the point where you think that this is the amount of money you'll need to retire if you're retiring at like 65 or whatever it was, right? So everybody did that. And then they were asked to go to the middle and start unrolling their ribbon, okay? And then at the end, like where they're standing now, that's when they're 100. So at a certain point, their white ribbon was gonna run out, okay? And then the blue ribbon represents, you know, how much they would actually need. And so they could see how far they were off from their calculations, okay? So it simultaneously sort of showed them, you know, like how close they were to being realistic. And it showed everybody else how delusional everybody was, right? So very anxiety provoking public spectacle, immersive analytics kind of exercise, which I thought was pretty funny. Anyway, if you can figure out a way to do this for carbon emissions, that's amazing. And that's it. There you go. Personal stories, traditional charts, creative charts, data sculptures, traditional maps, creative maps, be the data. You can match the different techniques to the different data stories and come up with some pretty neat things. We good? Questions, comments? All right.
Oh, no, I thought you were doing the third one.
There's a third one, but I think it's getting long, no? You want me to do it? The third one is about what to not to do, and it just shows you about all the different ways that you can sort of.
I think if you do 5 minutes on it, this was like my favorite one.
It's his favorite.
Do it for me.
I can do it super quick. You guys
should see it.
Not to do? Okay. Oh, you guys are so nice. It's amazing. You've been sitting here for hours. Okay. All right, just for Samir, let's do it. Okay, how not to. Hard to parse graphics are overwhelming. You know what? Me personally, I love them. Okay, like this here is one of my favorites, and it shows like different literary genres, you know, and so on over time and what came up, and you know, but your average person, you know, they don't want to sit there and take out the magnifying glass and try to figure out what's going on there. Okay. So when you're making a bar chart, okay, your regular chart, okay, you want your axis to start at 0. Okay, this first one that was originally published, this is such a, right? It makes Germans look like they're working twice as, this is what, your work hours per week, okay, for your average full-time worker. So I was trying to sort of display how much harder Germans worked than say the French. Okay? And it looks like Germans work twice as many hours as the French, right? On this one, but that's because it starts at 36 hours. All right, if you started at 0, then it's hard to see because of this in the way. You know, if you compare Germany to France, you'll understand it's not that dramatic, okay? Right, so really, if on a bar chart, you want to be honest, you're gonna start, okay, your x-axis as 0, please. Line charts do not need to start at 0, okay? This is a line chart, and obviously the climate crisis doesn't look like a biggie, all right? When you start at 0, you know, like if the Earth were like 0, I tried to look it up, but you know what? Like it's uninhabitable. Everything's dead at 0. You don't need to do that. The ice age sort of started like the last ice age. It was only like 4 degrees colder or something like that. Okay, so no, this is not useful. Line charts, you need to use
your common sense, okay? And you start it where it needs to start. Even this is, you know, you don't need to start as low as 55, but it's better. Are we good? Okay, what else? This is really complicated. And I'm gonna try to summarize this. And when I do, I'm not trying to say that glyphosate doesn't have an impact on thyroid cancer. What I'm trying to say is if you're gonna try to show that glyphosate and GMOs, you know, influence cancer rates, then you have to be honest about it, okay? In this case, we got two problems. The y-axis doesn't start at 0, okay? So which will skew the way that you're looking at the bars, okay? And then there's another axis here, right? And it starts at -10, which is like minus 10,000 tons of glyphosate. It doesn't work. And they just did it like that so that they could sort of take applied, like this line, make it coincide nicely with the bars. You understand? Okay, but it's not a painting, it's a data chart. If it doesn't match, it doesn't match. This doesn't mean anything, okay? You'd be surprised what gets published. Okay. In this situation, I'm gonna move this again. Can anybody, like you guys are science guys, right? All right, what's wrong with this? What's happening? Are you seeing it? You're like, what's going on at the end of the x-axis? It's like this is the 90 percentile and 99 and 99.9. It's like they don't want to end the graph, right? And so they started linear and they go logarithmic, okay? For those of you guys who know that, you know, for no reason. I mean, not only for no reason, this would be so much more effective if they just stayed linear, because then you would see what they were seeking to show you, which is like the hockey stick thing, you know, inequalities are going like this. They're not going like, I'm not sure, okay? You see that? Don't do that. Okay. Here, okay. Python isn't a value. All right. If you're going to have a y-axis, okay, it needs to measure a value. Okay. It can't just be random companies. You see that? I mean, I think this graph kind of says something, but it's confusing. Okay. So this was really good. Okay. So 2005, Florida enacted the Stand Your Ground law, and the Stand Your Ground law just says that, you know, if someone's threatening you, you can shoot them in self-defense and get away with it, okay? So what is it saying? Do you see it? Some of you guys are good. I think you see it right away. Yeah.
Upside down.
It's upside down, right? So anybody reading it will be like, oh, look, gun deaths have gone down. Since everybody understood they could get shot for threatening other people, right? Like perfect, right? But actually the 0 on the y-axis is up above. So it's like, you have to read it upside down to understand that, you know, after Stand Your Ground was enacted, gun violence sort of, or gun homicides went through the roof, okay? Funny enough, I did like a Google image search. I was like, okay, did they actually like publish this? This came out of Reuters. It did get published in Reuters and it got picked up in Business Insider, but lucky for Business Insider, the journalist read it upside down. And they were like, oh yeah, okay, yeah. Gun violence has increased, right? I don't know how, but anyway, this person who's obviously someone like me and not very used to what, you know, looking at stuff, they were like, oh yeah. And they told the story as it was meant to be told, but someone else had to write in and say that the graph was upside down. Okay. Okay. the y-axis needs to start at 0. Again, this is like the reverse, okay? And it's about proportional ink, right? If you're depicting proportions, then the ink you use to measure that proportion needs to be proportionate. And why it's important is this graph, if you look at it casually, and this is about the top 10 most read books in the world over the last 50 years, it seems to think that, you know, over the past 50 years, the Diary of Anne Frank sold half as well as the Bible, right? Diary of Anne Frank, Bible. Right? But I mean, this is decoration, right? So, I mean, what most people don't read when they read this is the Holy Bible sold 144 times more than Anne Frank's diaries. You understand? There's a huge difference. So you need to use proportional ink. You need to get rid of all of this bottom part. I know it looks pretty, but it confuses people. It's hard to read the graph, right? Again, it's super subtle. It's super subtle. I don't think if anybody, I don't know if, oh yeah, I wrote it down. I gave it away, right? So these circles were drawn using the radius instead of area. And when you use the radius to say, okay, 31% versus 30%, it exaggerates the size of the circle, right? It's not useful.
It won't probably.
Huh?
No, you won't have to move it.
Oh, wonderful. Okay. Okay. This is more badly proportioned ink. All right. So look, I know it's trying to talk about arable land per capita in hectares per person. And the way it's done, it kind of seems it make it look like if Canada already it's hard to read. Okay. But like say you get over like the actual trying to read it part. And you see that Canada is B, so it's the second line here. And you compare it to like the United States, which is H. You would think that Canada has way, way, way more arable land per capita than the United States. But just because the graph sort of curls around itself, right? It's just the length is distorted. So what the numbers are telling us is that Americans have a third of the arable land of Canadians per capita, right? But the way that the bars are done, it makes it look that like Americans have a sixth of the arable land of Canadians. Do you see that? Like, you know, when you're running a race, you want to be on the inner circle unless you're like, you know, there's a reason why they do it the way they do it, right? Am I making any sense? Okay, great. I'm not sure. Okay, again, proportional ink. All right. All right. So this is a bit different, right? This graph here looks at deaths for each group of people. Okay. So ink is used to represent the fraction of deaths and not the total proportion of deaths. And you would look at it and you'd be very scared for your toddlers because, you know, there's so many toddlers dying, the little purple thing here, dying of accidents, okay? And you're like, oh my God, I never knew that so many toddlers die of accidents. I need to be a helicopter parent, okay? Because it's not measuring absolute deaths, and proportional deaths, it just says of all the things that toddlers can die from, they're going to be most likely to die of accidents. Obviously, like older people, they're going to die of cancer. Toddlers have less of that. So your average person is going to look at this and be scared for their toddlers, right? But what it really should be doing is showing, you know, just like absolute numbers of deaths. Are we good? Okay. Don't make it a funky 3D graph if you don't have to. It just makes it harder to read. Okay. I don't have anything else to say about that. So here, the horizon line sort of disappears to the left. Okay. This is a distorted graph. And when you distort the graph, you distort the data, okay? There shouldn't be a vanishing point to the left. You'll see that the lines kind of sort of go towards the left and, you know, if you were to go on that, you see that? They're crooked. Don't make the lines crooked. Are we good? That's it. All right, you got all that? Okay, good.
We got a big round of applause. I told you the last one was the best one. That was crazy. The murder one tricked me too. I was like, oh yeah, that law was good. And I had to read it twice before I got it. So, and then it took me a while. She showed me this presentation before. The one with the curls, even until she said at the end, like the idea of like the curling, anyway, really a lot of stuff, great stuff. So the way it's going to work now, Joel's bringing food out. We're going to eat. Okay. We're going to take, yeah, you earned it. 45 minutes, 48 minutes, and at 2 o'clock. So some might argue we're accomplished. We have looked at Our World in Data as our inspiration. We've downloaded data from Our World in Data. We've stored it locally so that we can interact with it through Python and not have to go to the website over and over again, not have to make a public copy, whatever. So we've stored it in our drive. We've made that connection, right? So let's just go and run these over again. Right? We saw that we had access to our drive. We were able to import the data, take a look at it. We call it DF. We see it's got all these rows. We've answered a bunch of questions. We've explored the data. We've learned how to slice, I would say. A lot of good stuff in that cell. How do I get one column? How do I get a subset of the data? Dot loc is one way to slice. You can also just slice without dot loc. You can say df square bracket and then put some condition inside. This is a condition. What do you mean a condition? A condition meaning like a double equal sign is a conditional check. I want to know when the entity is equal to Canada. That's going to give me a bunch of trues and falses, and that will allow me to slice df to give me something less smaller than the whole data set. We could do double slicing, where I want multiple conditions. We could do a condition with a not. We could do a condition with an is in, because maybe you don't want necessarily to equal one thing, but equal one of many things. So is in is super handy in terms of slicing the data. Accessing certain things. How do I access one column? We've seen all that. And we learned about group by. Okay, that's a big one. Group by allows us to take the data, split it up into a bunch of groups, and then do something on each of the groups in one shot. So here, for each of the groups, get me the each of the countries get me the get me the annual emissions, and don't just do one statistical function on it. Give me the all the statistical functions. Describe is very handy. And then I showed you as a quick example. Oh, come on. You know, we haven't even learned any of the visualization libraries, but it turned out Pandas, which is not a visualization library. It's not for making graphs, but because the people in Python are all friends with each other, the people who made Pandas were friends with the people who made Matplotlib. They said, you know what? We'll make it so that we can, without even learning Matplotlib, because this is actually made by Matplotlib, but by calling .plot on the right thing, I was able to get a bar chart without learning Matplotlib. So that's super cool, handy.
A little limiting because you had to really know exactly what you wanted beforehand. But nonetheless, it gives us a good start. But this is nowhere near as pretty. This is not going to win you the data journalism challenge. Okay, we need to at least be able to make a line graph, some time variance. There's a little bit of a story here, but not really, because this doesn't even take into account population. Doesn't even take into account time. We have time in the data set, and you're not even using it. And I would argue maybe you should talk about the number of people in a country, because a country is defined by the number of people in it. So we want to go further. So let's explore a little bit of visualization now, especially now that you saw like what the best visualizations in the world can look like, and what the nicest visualizations that can suck can still look like the bad examples we learned about. And see if we can make some simple graphs. They're not going to be as amazing as what we saw, but they can still tell stories, and we can still take a lot away. So we're going to set out as a goal in this second chapter to visualize the data a bit more. And then the third chapter will be to combine the third data set. Okay, that's another data set. And I think then you're off to the races for your actual challenge. So if I could do 30-40 minutes on one, 30-40 minutes on the other, I think we'll be okay. So I want to finish talking by max 3:30 and then give you guys your challenge. Okay, here we go. Seaborn. So Seaborn is really, so in fact, all plotting is truly done. Almost all plotting in Python, the majority of plotting is done in this thing called matplotlib. And if I were to teach you matplotlib, or if you guys are trying to learn matplotlib, you will see it's quite hard. It took me years to understand it, to do it well. Otherwise, it was just like, I hope Stack Overflow has the answer. I hope someone has answered this exact question and just gives me the code, because every time I would just copy paste the code and thank God it worked. But to come up with my own matplotlib code, to do what I wanted, not hope that someone else had wanted the same thing, really took me a long time. And I don't think I'm the only one, because at some point, a lot of people were like, we need to make this a little easier for people to make graphs. So somebody went and made Seaborn. Seaborn is what we call a wrapper around matplotlib. It allows you to do in one line what in matplotlib would take you a lot longer. But it's still, because it's built on matplotlib, you can then work on it. So I'm going to start by looking at Seaborn. Okay, it'll go faster. So we're going to import it. It's a library. It's a part of Python. Import Seaborn. However, just like we're lazy and don't want to write pandas, we want to write PD. We're lazy, we don't want to write Seaborn for whatever reason. I don't know why. The convention is SNS, but you could just write, as S. So we're going to import Seaborn as SNS. Okay, so that worked. It imported correctly. And I want to make a plot. I want to see something. Well, I think the goal here, what they're saying, this is my chapter, my mini challenge I'm setting for us. Our goal is to produce a plot which will allow us to compare the emissions of G20 countries over time. I said G20 as if I was going to list 20 in the list. I'm just going to do like 6 or 7, the 6 or 7 that we had up there, right? I've already made a thing called DF plot. Oh, I don't want this. Okay, so I had taken only years over 2000. Let's get rid of that. Okay. So DF plot, which is just the countries I care about for all the years that we have. DF plot is a subset of DF because it is just the countries that I put in that list earlier. And you can add more countries if you want. But we're going to start with this. Okay. Did all the countries that I wanted make it in here? Australia, Canada, China, France, India, Russia. I thought we had Brazil. Why didn't Brazil make it? So this is interesting, and neither did India. Yeah, but why didn't India make it? Okay, let's see if that helps. Did Brazil made it this time, so now we'll have an extra bar for Brazil.
Good. Did India make it? Okay, good. All right, so we're okay. Okay, this is at least, so that's interesting.
Sometimes you go fast and then you realize the only way you notice that you missed something is by like, oh, there was a mistake. Well, because it didn't complain that there was no country called BRASIL. We had to notice BRASIL was one of the countries, but because .in just said, were you in the list or not? If you're not in the list because you were spelled wrong, it's not going to put it, and we were missing a bar, even though we should have that country. These kind of things you have to do yourself. You have to look and say, how come one of those was missing? Okay.
All right, so we got all our countries that we wanted. We got DF plot. So this is how easy it can be. SNS dot line plot.
Okay, so I have to put a bunch of stuff in the SNS library. The SNS library has lots of plots. You can make heat maps, you can make bar plots, you can make scatter plots, but we're going to do a line plot because line plots would be handy for something over time. What I like about Colab is that I have all the documentation, what they call the doc string. Okay, so the people who wrote this code, this function, somebody wrote the line plot function that I'm calling, and they want us to use it, so they want to tell us how to use it. This string here, this is called the documentation string. It pops up right there. I don't have to go somewhere else to go look it up. And it says here that the first argument is data, then X, then Y. So what data do you want?
I'm going to want my data to be DF plot. I want my x-axis to be year. And I want my y-axis, right, the height, to be, I have to always copy and paste it, annual CO2 emissions.
But the thing is, what this is going to end up doing is give me, it's going to go for each year, give me the annual CO2 emissions, but I'll make a line plot, but I don't understand the specific countries. But each year is going to show up multiple times for even countries. So I need to tell it somehow to make multiple lines, one for each country. If you look at the seaborne documentation, which I'll go to in a second, the argument that we care about is X, Y, hue like shade, hue, like the hue of green that suits me well, hue, H-U-E.
And we want the hue or the color to be the grouping variable. And that is entity.
Okay, so you're telling Seaborn, use the data that I just gave you, the F plot, make the x-axis year, whatever's in the year column, make the y-axis annual CO2 emissions, so that is my how high I want my graph to be, my points to be, and I want it to be grouped by entity, meaning the hue or the color of the graph. And if you run that,
Oh, come on. With a capital Y? Yeah. Amazing. You are data journalists.
you've done a graph. Right? It's pretty powerful. You can do anything. It's so much harder to slice and dice the data. It's so easy to make a graph. Well, that's the magic of Seaborn. Before Seaborn, we would have had 4 hours on Matplotlib. It would have taken forever to get this Matplotlib. However, this is still a Matplotlib product. And so what we're going to do is, because it's not terribly pretty. Did everyone get this job? No? Scroll? Yeah.
So that chunk of code.
Okay, so you imported the Seaborn library. And you said Seaborn, which is SNS. I want you to call your line plot function I want to make a line plot, because I want to look at things over time. I want you to use data that's already been subsetted for just a couple of countries, because if we didn't do it for a couple of countries, we would have had like 258 lines there. Right? If I just want to see here, watch. This is what happens if you don't subset it.
If I made the data not DF plot, but DF, it might even choke. The legend is ridiculous, and the graph isn't even there. I don't know where the graph is. Right? There's just too many countries. Oh, there it is.
Right? So it actually did work. Okay, but I don't get anything out of this, is the legend is too big for me to even see anything. So that's why doing the subset on just the countries that I'm interested in
Makes it a bit more viable as something we can work with. Okay, so let's go back and make sure that we only do the country that we're interested. You can add a couple of countries if you want above. Okay, here we have just a couple of countries.
And so we see, what do we see? The red one is China, leading the pack as of the year 2000s. Really, it's what I look at here is emissions really started going up in the 1900s. And the US led the charge. They were the first to really start emitting a lot. Then but everybody else started emitting more in the 1950s. And China led the pack and is now way more. Everybody else was the third. India's third. Who's pink? Russia's fourth. And everybody else is at the bottom. And how much scale are we talking about? Well, at least, see, this is the nice thing. The people who made these packages already saw the next presentation. They said, we're not going to buy deep. If you want, you can go and break this. You can go and make the y-axis, x-axis start here. You can make, you have to be intentional in doing the things that she had them not to do. But by default, it set them in beginning at 0. Although I know that was your argument, line plots don't have to start at 0. But nonetheless, the point is the default parameters for Seaborn's line plot will do the right thing for you. You would have to go and do the things to make it bad, make it upside down, you know. So what I'm trying to say is the defaults in a lot of these packages are according to best practices.
So this is good. I see something. I'm happy, but it's not really that pretty.
I also don't love the fact that I don't have grid lines. Good graphs, you got good grid lines. I should be able to like trace back as to like what year was this little peak and how much is that? I'd also have like to do a bit better. So remember, like I said, Seaborn is a wrapper around matplotlib. It allows me to just use one command, but it is still matplotlib. And hence I can control Seaborn via matplotlib. And this is a tough thing to sell, but I'm giving it to you as a recipe. You don't have to totally understand what I'm doing. But if you do import matplotlib dot high plot as PLT. Okay, so that is what it's saying is, I know you imported Seaborn, but give me the matplotlib, which is like the heart of it. Give me that too, and give me a specific part of it called pyplot, which is Python plotting. Little history, matplotlib is actually based on a proprietary software from a long time ago called MATLAB, which when I was in engineering school, I would use. When you guys, some of you go on engineering school, you will study MATLAB because it is very powerful, but it's proprietary. And they were the ones, I think, that company that really, those people were the ones who defined what we call, you know, how do we compute with graphics? Anyway, just so you know where that comes from. But I want the Python part of it, call it PLT. And if I do PLT dot style dot use ggplot, so I want matplotlib to control the styling. So I import pyplot.plt, and I want matplotlib to use a style. ggplot, what's that about? Well, for those of you who go on into more medical sciences or pure statistics, you're going to use not Python, you're going to use R a lot more. R is another programming language, very popular with statisticians. My brother is a professor in statistics and he made his chops in R. And in R, in that world, they don't have pandas. They have different heroes. They have different celebrities. And in the R ecosystem, there's a thing called the grammar of graphics, GG. And ggplot is a package inside R that just blows it out of the water in terms of making very nice graphs out of the box. And Python was like, that's a good idea. We're going to steal it. We're going to take those styles and let it so people in Python can import those styles. So just by doing that, I'm pretty sure we're going to get an improvement. That's already better. I didn't do anything. I just said matplotlib control the style of everything in my notebook and make the style match the ggplot R people. People from R do this better. They always put nice gray backgrounds. They always put grid lines. They choose nice color palettes. As a default, it already looks better. Can't argue that this is not better than yellow. Yeah. You do have to reconnect, but it usually gives you a warning. It gives you an answer. It said, did it ask you to reconnect? Yeah, that happens. Yeah, Google's a business. If they think you're asleep, they're not going to keep paying for your VM. But usually you reconnect. But usually they're doing autosave also, so you shouldn't have lost them. But that does happen. Is everybody connected again? Is everybody? I forgot to do it because I did lose connection. I didn't see it.
Many students are experiencing the same thing, like the session was.
It was cut out, but if you reconnect and run each cell individually, we're back. In the drive. I hope that's weird because drive is so heavy. Okay, I'm gonna take a minute I'm gonna take a breath. Does everybody have this? The majority of people have a graph that looks like this. They would control the style. Yes. I'm giving you an error. Okay.
Okay, I want people to catch up on it. So what I'm gonna do is I'm just gonna talk for 2 more minutes, then I'm gonna come around. Okay, Jeremy's gonna take a look. Okay. This also is not awesome. You've taken some classes. Graphs should have titles. There's no title. Thank God, at least it gave me an x-axis label and a y-axis label. That's good. Like I said, these graphs do have best practices. But I should have a title here. It kind of giving me some kind of thing. So I'm just going to give you a couple of little pieces that we're not going to take time to explain each piece, but if you copy along, you'll have the recipe. What I'm going to do is up here, this is a standard line that I put on top of all my graphing efforts. Okay, so what did I do there? I added a little boilerplate line that's going to come in super handy soon. Above everything, I wrote big, comma, AXS equals plot dot subplots. Because what you're going to see very quickly, remember Vanessa talked about one of the types of ways of stories you can tell
is comparing things, comparison. It's one thing to make one plot, but it'd be nice to be able to have two plots. Subplot.subplots is going to open up your world to making multiple plots, making one big one, one small one, run right next to each other. Just by calling that at the top opens up your world. But the thing is, when you write plot.subplot, it gives you back two things. And so what two things does it give you back? It gives you something called the fig and something called your axes. The fig is what I'm going to use to save the object. Because let's say you guys have to make a data journalism story. Maybe you want to take the picture and save it as a file and put it into a PowerPoint presentation. Put it on a WordPress site. How do we save the image that's produced? That's what's going to be what fig is going to be useful for. You can use the fig object to control the size of it. I want it to be taller. I want it to be wider. So it's more the file part of the picture you're making. AXS is for axis. It's the actual plot. Okay? And so that's the thing that we're going to use now to put the plot. And that's why in the Seaborn line plot, I actually said, make your axis the axes object. Because now I can do stuff like this.
It's the same code, but now watch, I can do this. I can say axes dot set x label. Obviously, that's garbage.
But the point is, I can change the X label to be exactly what I want. You can set the X label because you had no control before. You see, Seaborn out of the box, like I didn't know anything about plotting. I just said I wanted a line plot. Here's the data. Here's what I want on the X. Here's what I want on the Y. Do it. And it gave me a pretty good thing. But how did it figure out the X label, the Y label? Well, it's because it's relatively smart. But sometimes it's not what I want. I want it to be else. I'm kooky and I wanted to say HHH as the X label. You can control these things. And I'm showing you this is how you control it. By having the axis
and then setting the X label explicitly. Okay, so obviously this is garbage. I'm not going to do that. But maybe what I want scientifically is to say I want the X ticks. You can, I'm not going to get into this because you're really losing ourselves in the weeds here.
Maybe you want this not every 50 years. Maybe you want grid lines every 10 years. You can do that. You can say, I don't want this, I want these kind of angled off a little bit. You can, because sometimes you'll have your ticks. These are your tick labels, because these are your ticks. Your tick labels will be super long. So you're going to want to rotate them a little bit so they don't bump into each other. You can rotate your X tick labels. You'll do all of that through AXS dot. And where are you going to learn all the things you can do? Matplotlib. Okay, so there's two things happening. Seaborn, you don't want to learn Matplotlib. You don't have to. Seaborn gave us something right out of the box that was actually fine. But if you look at what Seaborn gives you when you want to get a little fancy, you bring Matplotlib into the picture with that little boilerplate line. You take the axis object, and then you start talking. I want to change the label. I want to change the title. I want to move the legend. I want the legend to be grouped a little differently. I want to change the color palette. I want the color palette to be more a divergent rainbow, or I want it to be starting from hots to cold. I want it to go in the reds to the blues. You can do all that finesse and control through Matplotlib, even though you started with Seaborn to give you the main graph. Okay, so that's the big message I want you to hear today. Make your plots straight out of Seaborn, finesse them with Matplotlib. It's infinite the possibilities what you can do. So I don't want to get too much into it. So let's just get something that's not terrible. That's not terrible. Okay, so I have now shown you how to make a line plot. Okay, but is there other stuff I can do?
Well, if you want to see all the fancy things you can do, just go into Seaborn. Their gallery, I mean, your imagination, just there's all sorts of things you can do. I don't even know what am I supposed to show you? Gallery. And the nice thing is they give you the recipes to do it. Like you can make heat maps, and the heat map, like this is the code to make that map. Just copy and paste that code to one of your cells, and it will make you that. What are you looking at? I don't know. It's months of the year, years of the last 20 years, and the heat is the delays, I think, or the number of flights. So here I'm seeing that there's lots of flights in the 60s in July and August. Seaborn actually comes with data sets also. SNS got low data set. So there's actually publicly available data set in my plotting library. Why is that good? Well, because it allows me to like prototype plots. If I can get this to work, then I can maybe change the data and make that same heat map for the data I have. So I encourage you to look at the gallery of Seaborn to give you ideas on what you might want to do for your data journalism project. Because sometimes there's lots of really good ideas out there, but the nice thing about the gallery is that it comes with the code snippet. Okay? And notice they do that same little line, not crazy. F, AX is plot dot subplots. And why do they do that? Because now I have nice control over the figure size or all sorts of things. I can make like a grid of plots. I can do all sorts of really fun stuff. I am losing my voice. Okay. There is actually a facility inside Seaborn to set a theme. Okay, there's certain themes, like when I controlled the style to be ggplot, you can do that with themes in Seaborn. I'm trying to get you guys thinking like, oh, what else could I do here? Go into Seaborn, click the gallery, see something you like, think how you could use that for your story, and hopefully you'll be inspired. That's kind of what I wanted to show you. Okay, already we got a nice plot. The real problem though, I hope you see, is that this is kind of course, kind of has the most emissions. What you notice is the ones with the most emissions are the most populous. If we're trying to tell a story about emissions, we have to take into account that in some places more people live there. More people live there, of course they're going to produce more. If we want to get a feel for where we're producing too many emissions, we should take into account populations. And that'll be what I'm going to show you now. How do I get population into here? How do I combine data from somewhere else? And that's my third chapter. Any questions? Combine data from a different source. Okay, so we want to normalize the data with respect to population. I've already heard it. Some people want to normalize with respect to something else. I want to combine another source of data. What we're going to do with respect to population is simple. And the thing is population isn't a static thing. We're already looking at time. So not only do I need the population per country, I need the population per country every year. Yes. Yeah. Yeah, that to me is a good starting point for anybody who wants to start making plots. Right? You do a little importing, you do that little boilerplate line that'll give you that finesse and control to get the plots out, control the plots. You do the Seaborn command, just give it the access object, and then you can do whatever you want. You can really control it the way you want. You know, like what we might have done here is control it so that each country is color coded by its continent, but maybe the style is different. So you can make it so I want them dashed like SUV. So that's that. Okay, so let's get to that new data set of population. And this is decent practice now we're going to redo what we did at the beginning. If we click this link, I take you directly to Our World in Data has a whole post on population over time. Okay, so here we are. Obviously, we're seeing that like China and India have been growing population over time. They were also the ones that were emitting the most over time. So can we put those two ideas together? That's fine. I want the data. I don't want this picture. So I hope you guys have it in you now to know where to go. Especially if you're using Our World in Data as the source. You go to the download tab. Right? You hit the full data CSV. It shows up. You go take a look at it locally. This is on your own machine. This is way bigger, by the way. This has country, year, population. This could be an interesting part because I'm not going to show you how to, like, I'm not going to use these other columns, but maybe what we really should be asking, is it the older countries that are making more emissions? Because this gives you not just the population total in every year, it gives you the population in different tranches d'âge. So maybe if we were to normalize and look at just young people, younger, oh shit, this is cumulative. That's super interesting. So this gives you total population. Next column is the population who are babies under 1, under 5, but this number is going to be a subset, like this number is a subset. Sorry. This is a subset, this is a subset of this, this is a subset of this. The numbers increase. The point is, you have the demographics breakdowns here. So I encourage you to keep this file on hand because you can do some interesting analyses just there. Which countries are aging faster? Which ones are silver countries and which ones are baby countries? And are those, is that related to who's producing the most emissions? My guess is yes. But now that I have it, if I want to get this into my Google Colab, where do I upload it? Into your Drive. So go ahead, you know how to do this. Go into your Google Drive. Where's my Google Drive? There's my Google Drive. I'm going to upload it. Of course, I already did. Now I'll have 2 files to work with. You know this. We did this at the beginning. Quiz. Upload the data into your Google Drive. And then go back to your Colab, refresh it, and you should see it. Copy the path. Make a new FP variable. Do another pandas.read CSV. Save the population. Let's take 10 minutes. I'm going to walk around, make sure everybody's got that. Okay, I want everybody to get into Pandas this other spreadsheet. I want to have another DF. I want somewhere where I can write DF population, and I want to run it and get something. I want to get that population data that I just downloaded in my Python environment. I'll walk around. Got Jeremy. We're gonna, if you guys need help, we can help you, but I want to make sure that everybody's got this new data set up. So I click, because now I'm sharing my entire desktop and not just the Colab screen. And for those of you who are here, you can listen again. I click this Our World in Data link, which takes us to a particular page in Our World in Data that has the data set I want. I go to the bottom to the download tab. The download tab gives me the opportunity to download the entire CSV to my computer. And it will pop up in your browser, but really it's on your computer. I click it to see the data in a spreadsheet on my computer, Excel, LibreOffice, whatever, but it's not useful to me here because my Colab can't see what's on my local computer. So now I have to get it from my local computer up to my Drive. So I go to Drive and I do new file upload and get the file up here. Once it's here, I go to my directory structure in the notebook refresh the connection, and hopefully it's there. Now, I don't want the file, I want the path to the file. So I do copy path. And I want that as my new file path as a string. And then I want pandas to read it in for me from there. And now it's in the collab. But of course, this is just printing it out. I want to save that as something else. And that will get me there. So I hope that works for everybody who's online. Everybody's in here. That was what I was looking for. You want another data set loaded up.
Why do we do it this way? Is there a URL I could have just gotten this data from somewhere? Of course you could. I'm also trying to show you how you're going to deal with it, because most of the time in your life you will be dealing with a private data set or something that should not necessarily be public. And if it's not public, that's the challenge. I have noticed in my life with tutorials on these kinds of topics that people use public URLs for public data set. And that's fine and good, but then when I end up tackling my own problems, my problems are on private data sets and I never know how to load them into Colab. That's why I'm going through this extra little drive process. By allowing you to see that you actually have the tools in your disposition to deal with private data sets also. And I will just use this as an opportunity to echo. You will probably never, ever deal with a public data set in your actual work. You will almost always be working with proprietary, small data set that should not be made public. They belong to somebody. And it takes a long time to figure out who it belongs to and everyone who participated and whatever. So just keep everything private until somebody says you're working on a public data set. Okay? So it's important to go through this. Why is he teaching you about Google Drive? Teach you about Google Drive because at least it's a place in the cloud that belongs to you, and that hooks into a Google Colab notebook very nicely. So it allows you to tackle any problem. You can't say I can't do that problem. It's a private data set. Now you can.
All right, well, this is handy. I now have a new data frame called DF pop.
You could have called it whatever else. You don't want to call it DF because it'll overwrite the original. And it has all my populations in it. I could go explore. I could go make plots. I could go get the average of every column and describe and all that. Not necessarily what I want. What I really want is I want to grab really these three columns. 1, 2, 3. I want to take those three columns and I want them to show up in my main data frame. Because for every country, for every year, I want to know the population was. If you were doing this manually, you would have a very long sheet of paper, 31,000 rows from the previous data set. Every country, every year, how much emissions. On a different table, you'd have a long piece of paper that had every country, every year, its population. And then I'd be like, well, can you put it together? And they'd be like, okay, I'm going to go to use this one, and I'm going to go to that one and look up this country, this year, get the value, and I put it here in a new column. Then at this country, this year, look it up, get the number, put it here. I want to merge these two. And that's what I want us to do next, is how do we merge two data sets? And we want to merge it on two variables. I want for every country, for every year. First of all, for those of you who are Excel ninjas, or who've done this in Excel, you'd be doing a VLOOKUP. And in Excel, it's called VLOOKUP. Okay? I've done it before. It works, but I actually have never done it. Oh yeah, because VLOOKUP works really well for one thing, but to do it for two, to look up the country, then for that country, look up the year, it's not obvious. So it's nice to be able to do it in Pandas where it's going to be actually quite simple. All right, let's do it. Where's the magic? So the magic comes from Pandas. P
D dot merge.
We're merging two data sets. Okay? I like leaving it up there so then I can get the doc string to show up, the doc string being the help. If you want to merge data sets, take the visual. I've got some data on the right and some data on the left. So tell Pandas which one's on the right, which one's on the left. So I'm going to do that. Does it matter which one's right and left? No.
But it'll help in a second. So I'm going to put my actual data frame that I started with there and df pop. But I only want a bit of pop. I haven't shown you how to do this yet. I'm going a little fast, but I just want, okay, let's go one step at a time. See df pop? It's a lot of stuff. I don't want all these columns. This is too many columns. I just want the population. I don't care about children right now. I want the overall population. Maybe your story will actually look at the children. Okay? But let's actually just get those first three. If I just want the top three columns, put the names of the top three columns. Okay, so that's better. So you take df pop, you put square brackets, and then inside the square brackets, you put another pair of square brackets and a list of column names that you actually want.
Another way of saying slice the data, but vertically. Only give me the columns I'm interested in. So now I've got the columns I'm interested in. I'm going to call that actually df pop.
I'm going to rename df pop here. And maybe what I'll do is I'll do this and put it here so it's all together. Okay, so now the advantage is I
read it by CS Pandas, read it in for me, but Brett, call it df pop. But before we go any further, can you just do me a favor and just keep those columns? That way, I have all these other things that. You want to keep on the columns? Keep on the columns. This is going to make it a little easier, especially because I'm trying to explain something quite complicated, which is merging. Merging is a complicated idea, but it's so crucial that I think it's important to learn even on your first day of Pandas. Your first day of data. Because if you're going to do any kind of storytelling, it is not interesting if it only has one data set. It's much more interesting. You have two data sets. With two data sets, you have to know how to merge. And so now I need to get this thing like kind of attached properly to the other table. And it's got to be done carefully. I would hate to the population of Afghanistan in 1950 be accidentally swapped with the population of Canada in 1950. Right? Like you want to really make sure the lookups work out. It's almost, this is one of those times where I was like, I don't even trust Pandas to do this. I think I'm just going to do it manually. But you want to make sure you do it right. Especially this is a double merge, meaning it's merging on two columns. So we're going to merge this. So the first one, I think is called left. This, what? Oh, no, you know what? This is one of those times where you really want to say, I'm going to say left equals this. Right equals this. Why is he calling them left and right? Because Pandas is giving me a merge function. And when you're merging, Pandas doesn't care what you're doing. It wants to know which data are you holding in your right hand and which data are you holding in your left hand. Okay, so that's what merging is. Two data sets, one in each hand, we're putting together. It wants to know and it wants to call them left and right by itself. So now we're going to say, you know what, I'm going to be explicit. The one I'm holding in my left hand is going to be called DF, the original data. The one I'm holding in my right hand is df pop, the population data.
And this is where it gets tricky, because do you notice something? Here, what's it called? Country name. Over there, it was called entity. Got to deal with it. So the way you deal with it, you say, well, what was it called in the left and what was it called in the right? Left on entity. Did year have a majuscule? Yeah, it did. At least it was the same in both. And in the data that's in my right hand, well, it's not entity, it's country name with a lowercase n. Capital year. It will choke and break down and eat away years of your life if you don't pay attention to this. I was gonna tell you, but I did, just like yesterday, right? Oh, shit, it was a capital Y, capital N, and this and that. It's really important. NS is just a tool. You're wielding that tool. It doesn't know, it's doing string matching. Because you're doing string matching, the strings have to be dead on right. And if you do, amazing. You have merged the two data sets. Okay, and now in every row, you really have two things. You have the population and the emissions in any country in any year. Yeah. You could do a rename. So what we could have done is we could have gone to DF population, renamed the country column, country name, renamed it as entity. So there is a rename function in Pandas. I'll leave for you. Look it up, it's quite easy to do. And often I do that actually. A lot of times I rename the headers to be for my, lots of reasons to rename headers. It happens all the time. If I have time, I'll show you guys how to use rename. It's not crazy. It's using a dictionary where you map for this one, I want you to name it that, this one, I want you to name it that, and you can rename your column headers. Yeah? Yeah. So what I'm saying is, Pandas, PD, I want you to merge two things. What do you want me to merge? Well, I've got two data sets. Pandas is if you've got two data sets, you've got one in each hand. So which data set do you have in your left hand? I've got the original DF, which is the emissions data. Which data set do you have in your right hand? Right equals DF population. That's what I have in my right here. Left on says, so now if you're going to merge the data, how do you want me to find the matching? What do you want me to look up in one and look up in the other? Well, in the left one, I want you to look up the columns entity and year. And in the right one, I want you to look up country name and year. And I want you to find wherever they match up, find the values and make a new column and do it. Right? That's what's happening. That's how I read that in English. What you'll notice is that you no longer have 31,000 rows. 31,000 rows of data before. The row should have the same number of rows. Yeah. That's exactly what. That's exactly. You answered my question. Because there were missing places for some countries. In some years, we didn't have the population. And so what Pandas did, just got rid of it. That's called an inner join. An inner join, which is the default, an inner join says only keep where it's common in both data sets and let the things you want to match up in the left also exist in the right. Okay? Sometimes that's appropriate. Sometimes it's not. Sometimes you want to keep one data set whole. You know what? It's super important to me that even the places I don't have populations for, I want to keep them. If you want that, you add an extra argument in here. This is a little advanced, but you write how equals, I want the left one. And what that'll do is that the left one matters more. And if the left one matters more, if it didn't show up in the right one, I don't care. But I want my 31,000 rows at the end. That's how, so if you just want what's common between some data set, don't do anything, don't do a how. Because the default for how is inner. Inner joins, inner merge. Okay, sorry, here's another thing. You guys are gonna go off, I hope that you guys are inspired to do this more often. And you're gonna go off and start learning these things. You have to realize that this data set manipulation in Pandas is a little bit like it's new age. It's hip, it's cool. Old school people who are like over 50, older than me, those people, they think this is really new age garbage. They work what they've been working on for the last 50 years of computing, SQL. Okay? SQL is SQL, which is structured query language. And so SQL is how real databases are out in the world. And then there's different types of databases or whatever. To be honest, I find those people a little bit snobby, but I get it. They've been doing this for longer than I have. The point is, if you're out there in the world and then you're trying to figure this out, I'm like, wait a second, I'm using Pandas, but I'm thinking about joining tables, and I'm getting, what about join? The word join is a SQL word, but join means the same thing as merge in Pandas. Just saying that. You go out there in the world, you find a tutorial, they're using the word join, I'm using the word merge. In fact, even Pandas has a .join function. I don't want to get into it, but just so I don't want you to get that mixed up. Joining tables, merging tables, roughly the same thing. Okay? Just I don't know why I got it. Oh yeah, if you're ever out there and you see what SQL is just old school data sheet manipulation, but powerful as well. Okay, so joining, merging, and how you do the join. If you want a left join, you're saying prioritize the data I had in my left hand. If you want a right join, prioritize the data I had in my right hand. And if you don't say anything, don't prioritize either. Make sure that the rows you keep are common to both. And when I didn't have anything, well, it reduces because it'll reduce to the one, I think 15,000 rows was probably the size. Oh no, look at that. My population data had 18,000 rows. So there must be some countries in that data for some years that don't even exist in the other one. So you get the commonality between the two. 18,000 rows in the population data, 31,000 rows in the other one, but only 15,000 had a common year, country row. Nice. Let's save this as DF, I don't know, 2. That's the worst, no. DF per, I don't know, what do you want to call it? Okay, I don't care. This is bad practice. Don't ever call things DF2. We should be having much more descriptive labels, but I'm getting tired. So there's DF2. And so now I'm going to work on DF2, my second data frame. That doesn't mean anything. It's like a 6th data. But this has got all the good stuff now. DF2 has got all the good stuff. Problem is, what I really want, I don't really want population. I don't really want emissions. I want emissions per person, emissions per capita. So this is one of those kind of things I didn't show you. I was going to show you at the beginning. How about if I want to make a new column? I want a new column where I take the amount of emissions and divide it by the number of people, because that would be a fairer comparison. Emissions per capita. You can do that. You can say, I want to do DF2. I want to take the annual emissions column, every entry, and divide it by every entry of population. And it gives you a series. Now,
taught this several times now. And I feel like I go so fast here that a lot of times if I was in a class with you guys, I would say, could you figure out what the per capita emissions are? And what people will do is they'll write a loop. For each row, go here, divided by this. They write a Python loop. It would be 3 lines, so it's not like it's 30,000 lines or something. But they write a loop that would go through each element and divide it by the corresponding element. But then they would try to save that somewhere and then put that back in the data. What I'm trying to show you is that this did that. It's a vectorized operation. It went through every row and took the corresponding element and divided by the element right next to it. No loop required. Okay, that's a core deep idea that we have to leave behind if you get too used to writing loops. And Pandas, you don't have to worry about that stuff. It understands that you probably, if you're saying you take this column and divide it by this column, what it means is you want every value in this column to be divided by the value that's corresponding in the column right next to it. But I want to save this into my data frame.
So I'm going to make a new column. And that's as easy as just giving it a name. DF2 is my data frame. Let's call it per capita CO2.
And now what you notice is I have a new column. So that's another thing that's going to happen. What if you're merging data sets, or if you have a data set, you want to do a permutation, you want to change something about it, you can easily add a column here. Okay, with a calculation. How? Give it a name, put it in square brackets. Pandas will know that this thing doesn't exist yet, because it's not part of DFL columns, and now it is there. And now let's get seaborn, let's go up.
Get that Seaborn code back. Let's copy our Seaborn code.
Okay, we're gonna go. I want to make a new plot, but now the data set is this thing called DF2. I still want X to be the year. Y, I don't want it to be annual CO2 emissions. It means a new column I made.
What did I call it? Per capita CO2. You might have called it something else. That's what I want as the y-axis. I still want the country to be the hue, the entity. Is it still called entity? Do I have a column called entity? Yeah, I kept it. Entities here, but country names here also good. Ah, whoops. Not super helpful because there's still there's all my countries. So why don't we do this? You guys, what am I going to do now? I'm going to subset it. I'll make a new DF plot. Is just DF2 with my DF2 sliced for entity dot is in. Remember, we had defined that countries list earlier. Nice.
And now we see it's really not clear who the worst offenders are. Yes? Yeah, I'm actually going to zoom out so I can keep a bit more of it on the page, just so you can see it all together.
So what I did was I did a little dot is in to just get a fewer countries because there's too many countries right there. Oh, no, that's too small. Oh my God. Well, I zoomed out a lot. I'm not sure how much you can see there.
Right now, when I look at that, sure, United States, but they're actually doing pretty good in the last 10 years. They've been bringing down their per capita emissions quite nicely. United States being the pink. See, this is another thing. This makes no sense. It's not a very good visual storyteller. It should at least try to match the colors of like something with a flag or something. I don't know. So United States is pink. I would never make, if I was to submit this for a true story, I'd make sure the United States had a particular color and a kingdom. And anyway, but the point is, pink is United States. They've been going down. Orange, in fact, the worst right now is Australia. Wow, I did not know that. Australia is leading the pack a little bit on per capita emissions. Canada is right up there. Per capita, we are emitting a lot. And China's middle of the road. They just have so many more people that normalize they're actually not per person. Now, this is complicated. The story is incredibly complicated when it comes to emissions. It's very easy to point fingers when you have a graph like this. If you have to say, well, what counts as an emission? They said they don't include land use change. That's maybe one of the ways in which some countries are worse offenders than others, because if you remove trees, like you can count that as an emission or something like that. Anyway, there's a deep science into counting emissions. Counting carbon emissions is not easy. And that's where you get into using your, yes. Yeah, I don't know why I can't. Hold on, let's try again. I don't know what's going on. Let's try this. Let's try this. Better? Okay, and let's go here. Share. But I think now you guys have a lot of things in your tool belt. Start telling a story. You know how to find a data set, and even if it's not a public data set that you should be publicizing, store it in a place so that you can do analysis on it in a safe way. You know how to take that data set, explore it a little bit, see what the column nodes are, what does each row represent, how many rows are there, how many groups are there in any of your categorical variables. You can do operations on each of the groups with group by. You can do statistical operations like mean and standard deviation and median. You can do all of them in one shot. You can make new columns by taking one column divided by the other column. You can get a visual with Seaborn out of the gate. You can finesse that visual using Matplotlib. You can get a different data set, merge it in, and make a story right out of the gate. I would say the story is like, I mean, this is not going to win anybody any competitions if you were to submit this tomorrow, but it's a start. I think personally, there's something to be said about some of the most populous countries not truly being the biggest emitters per capita. And now we haven't even talked about wealth. Go get another data set that has GDP on it. Take GDP, which is proxy for how wealthy the country is, get GDP per capita, and see if that has something to do with it. I'm going to take the luxury of another 3 minutes to just show you
something else you can do. What's my data set here? How about if we do this? DF3, this is terrible. I should never do this. I want DF. No, I'm going to work off of the original. Because what I want to see is a relationship between emissions and population for 1 year. I'm going to pick a year. And for that year, I want to see on the x-axis how much people there were, and on the y-axis how much they emitted. I want to make a scatter plot. I want to show you that you already have most of the things in your tool belt to make this happen. Okay? We're going to do this as a little quick run through exercise. So first thing I'm going to do is I'm going to take only the country. Actually, you know what? I'm going to take all my countries, but I'm going to take it for a particular year. DF, where oh no. Oh shit, you're right. I need it on DF2. You're right. Okay. I need to work off of DF2 as my start. I want when year is equal to 2020 was a weird year because of the pandemic. Let's go to 2010. And now I want a scatter plot where my x coordinate, my data is DF3. No, 3. My x coordinate is population. My y coordinate is no, let's use my new variable that I just made. My per capita emissions. Per capita CO2. No, because it got me all the countries. But here, every country got plotted as a dot. Not amazing. It's not super easy. Maybe 2000 was not a good year. But every dot. So, because if all my dots had come out on the diagonal, we would have seen very clearly. She per capita was making sense. You already have population. Should be emissions. All right, that was my bad. I'm going to do. I want CO2 emissions. And maybe we should trim it down to just the countries because it's such a mess with all the countries all at once. Sorry? No, because I want to see it. This is just to get you a different graph. I just want to give you a good example of a different graph. I want the country or entity to entity dot is in countries and for 1 year. There. And so here is a different way of thinking about the data. I don't want to look at it all the time. I want to look at one time. And what I see here, green one, China, huge emissions, but also a huge population. Down here, I have countries like Australia, Canada. The color, I'm not sure. Anyway, I've got a couple of countries here, low in population, low emissions, but then you've got weird, and you're talking about outliers, factoids, stuff that might be particular. You look at stuff that's not predictable. It's not surprising that the higher the population, the more the emissions. The lower the population, the lower the emissions. But this is ridiculous. This is what? This is India, huge population,
relatively low emissions. Well, why is that? Probably has something to do with their wealth. That it's a pretty poor country in general. There's a lot of people in India who are not making emissions. And hence, so that's an outlier that you could study and tell a story about. And here's something odd. This pink dot is a relatively low population, but pretty high emissions. Who is that? The United States. United States, relatively low population, but a high emission. Okay? So we talked a lot about the line plot and getting the line plot of time, but I wanted to show you that it took us nothing else, just change the word line to scatter, and we got to take a different perspective on it. Okay? This is hopefully all inside the tool belt. So I think I've done way more talking than I had planned. The challenge
Is what we'd like to launch. Maybe I want to call Joel up here. Don't call Joel up here. I don't know. Do you want to come up here? No, I go.
Please go ahead.
So,
Frame it and then we'll-
so the challenge is to, so I'll be honest. Okay, let me just show you what the challenge was supposed to be. So I have it here.
Can I share the document with them?
I was gonna open it here. Oh, you're gonna put it on Discord? Yeah, put it in Discord and I'll open it up here. So there is a Word document we produced. It's the same one, right? Oh, could you just give me the link then again? Or no, sorry, it's the same link. So let's open up the challenge. Let's close up any garbage windows here. On Slack? Okay, thanks. Where is this? Yeah. Okay, so what is the official challenge?
So this is the official challenge for tomorrow. You can read the intro, but basically say we should all stop working on, unless it's a health science problem, everybody should stop working on what they're doing and just work on climate change. But and it doesn't have to be data science. Go make a better battery. Work on desalination. I don't know what, all of us should stop what we're doing and either work on solving the world's health problems or solving this. But anyway, that's what this first problem is about. We did the warm up. Okay, we did the warm up. And I think we did a decent job. The challenge is to do the same analysis, or at least analysis along the same idea, but instead of looking at the different countries of the world, look at our own home. Okay, we live here and we probably the highest chance of affecting change will be here. Okay, it can make the problem less intractable. So I wanted to introduce you to the Statistics Canada website as a source of data. It's a very good source of data. Okay, and so I'm going to click. Control, click, there it is. Statistics Canada is a website. I think everybody online should still be able to follow along because I'm doing the website, the screen share. Statistics Canada actually has a lot of good stuff. I have to go back to my own documentation to say, how do I get there? Scroll down to access our data. Okay. So you go here, you scroll down to this wonderful link here called access our data. And this is like their data cube. Okay, I don't know what you want to call it, but they have made a lot of data available publicly, no paying. And because of Statistics Canada, it is curated. They have taken a lot of the null values. They have made sure that it's trustworthy data. Okay, but there's so much of it that it can be daunting the first time. So I'm going to guide you through to how could you just, you know what, I don't want to be original. I've been in here for 5 hours. how could I just do this all over again? At the provincial level, I'm gonna basically point you in that direction. But I'm gonna hopefully show you along the way, what are some other interesting things you might wanna do.
So if you go, sorry, after looking at my own instructions, we're gonna, I think he shared this with you. If we do filters on environment, okay, so we go to the filters. Environment. Okay, I want annual on my filter for frequency. Oh, there it is, environment. There's environment. And I got annual, that's it? Okay.
Then you had province and territory as well. As one of the filters.
There it is, yeah, there it is. Province or territory. You got to do those three, otherwise you'll be lost in the weeds. Because even then, you still have 18 possible data sets brought back to you.
And you're looking for physical flow, which I'm not sure which number that is.
It was the third one last week when we checked, but
This thing is constantly changing. So let's scroll down until you see the physical flow. Now it's the fourth one today. It's a living thing, StatsCan.
they're constantly changing it, so search results can vary by time.
But that one, physical flow account for greenhouse gas emissions. You click that, and you have data here. And it's by Canada and by province. So then you go and pick the reference period. Let's go back to at least 2009, because you want to do at least 10 years. So this is a bit different.
If you, we were doing it at least 100 years before or 50 years before. In the StatsCan website, you only have access to the last 10 years if you want it by province, but we'll do it.
What else say in the instructions? Download data. Download options. CSV. Open her up. That's not what I want. Okay, so that's not great. Okay, well, you'll see it's not as obvious. I forgot which button to click because you have to be careful, because to open it, my version of Excel is having trouble opening it because of the commas that are in the commas in the numbers. So there's some other things. This has changed. Point is, you have years, you have provinces with a little bit of finagle. Yes?
The database version?
This one? I think I'm killing my computer.
Point is, you should be able to do it. And you should be able to actually roughly go figure out what the population is for each province for the last 10 years. You'll find it on StatsCan, you'll find it even with a Google search. Merge it We get the per capita emissions for each province over time, and figure out which of our provinces are the biggest emitters, and where do we need to do most of our work. But what's interesting is there's other columns here where you can say, I want to look at emissions based on consumption, which is more individual action, as opposed to production. Because Alberta's going to get knocked pretty hard, but they're producing a lot of the gas that we're all using to drive. So that's not a fair comparison. So maybe you want to look at consumption-based CO2 emissions. There's a lot to learn in this field, and I'd like to use this as an opportunity for all of us to learn about it. But the challenge, and this is a little bit,
the challenge as stated in that document is to produce a story. Oh, it worked. Okay, yeah, there it is. There's the data for all the provinces over 10 years with their kilotons, but you've also got interesting categories because the different ways of measuring. You actually know the number of households. Tons of good stuff in here. And I think you have the chops now to look at it. So what's the challenge? Develop an argument based on what you see, and feel free to leverage other data sets in Statistics Canada. But you have to, it's a bit vague, but I would say that the real challenge is to captivate my attention for 3 minutes. Okay, tomorrow you present something that in 3 minutes you hold our attention to tell a real story. Or not 3 minutes of talking, but 200 words of writing. You want to put something that could make it up onto the upshot, onto CBC. Probably not as amazing, that can look good on my phone, but something that sets up what could be a data storytelling headline. Something that people would want to Twitter. Did you see this? This is crazy. That's the kind of story that we want you to go and spend time developing. And we hope that with a little bit of help, teamwork, recipes that I've given you throughout the morning, you can do that. But it can be anything. However, what you actually have to submit is some kind of image for your visualization. For those of you who go crazy, make an animation. Awesome. We'll figure out how to make, an animation counts as an image. It's a nicer one. A 200-word news story. The code you use to get there. Submit it as a Colab line. 3 to 5 minutes. I mean, some people feel comfortable talking 5 minutes. You have 5 minutes. It can't go longer than 5. Should be shorter than 3 though. In that ballpark of being able to talk and give an engaging presentation for your story. Be inspired by our old data. Feel free to go into thinking about classical graphs, infographics, but that I haven't shown you how to do because, to be honest, I don't know how to do them. If you're going to make an infographic, you're probably going to do it by hand or on PowerPoint. So let's say you wanted to do, that example that Vanessa gave of the Brazilian flag. Well, I don't really know how to show you how to do that in Seaborn. Okay, you would have to do it yourself. Maybe you will make a drawing with your hand, and we absolutely encourage you to do that. Okay, do not by any means, because we spent the last 5 hours learning pandas and Seaborn, say that's what you have to do. Be creative. The goal isn't to create the best picture. The goal is to captivate our attention and tell an engaging and true story. So if that you're going to accomplish without this pandas Seaborn garbage, go ahead. Use your imagination. That's your true tool. Like I told you, all this stuff is just one way of attacking the problem. But really the values and how you see the problems in the data, and the problems in the story. And I'm going to let Joel take over.
Can I just
Go for it.
Just while we still have our online folks, we're going to do a little bit later. We're going to do a short presentation on where to submit, how to submit, what the fields are for that. How many of you have used DevPost before? There's some hackers out here. Okay, so this is a platform for hackathons. And if you want to do hackathons in the future, you'll likely come across something like DevPost. So I ask you all to go to, and I'll put this into the Discord, to go to devpost.com and just create an account. And that's the starting point for instructions later. Now we want you to not be buried in instruction. We want to give you some time to actually engage with the challenge. But there will be simple instructions for how to submit your projects and what we're looking for. Essentially those points that are in the challenge accepted, except spread out over an example submission. So you can follow that as your template and you don't have to worry about that. And we wish you good hacking. We're looking forward to the stories that you'll come up with, and the schedule will continue to unroll. So for those of you who are here, in a couple hours, we're going to order some pizza. Pizza and snacks. I mean, it's also a snackathon. And we're angling towards submission for 12 o'clock tomorrow. Okay. So good luck, everybody.
I'll just say one
Yeah.
thing. So the thing I was gonna say before. The challenge as originally intended, and I still keep it, it'd be nice if you guys looked at provincial or Canadian data. Okay, get used to using StatCan. I think if it was me as a judge, I'd give more points to that. However, it can be challenging to the point today isn't necessarily to do that. The point is to engage with the topic and have a nice rich data set. You might find an interesting data set that's more international. So if I was going to say there's one true criteria on the story topic, it really must be something related to climate change and emissions, ideally. Okay, because that's just to make it a bit more structured for you. Because if you go off into climate change in general, some of you might end up looking at maps. If you feel ready for it, go for it. But I'm just telling you, dealing with maps, it's a whole other ballgame. Okay, how do I make a map? How do I draw the contours? It's like another 5 hours of learning. If you want to, go for it. If you don't, just focus on the amount of emissions, people, ages, demographics, wealth. But you could do it at an international level. Okay, because there's actually lots of nice wealths of information out there at the international level. And I wouldn't want you to feel limited because what you want to do doesn't exist at the federal level here in Canada, right? What you're going to find on StatCans is perfect, but limited. Whereas what you're going to find on the world will be much broader. So if you feel that you have a story to tell that you want to try to attack that's more international, go for it. However, we wanted you to focus a little bit on Canada if possible. That's it. All right. Thank you. Good luck.